from left to right, atomic radius decreases. This is what we learned, this is what we are expecting. But S2 தானே, S தானே, 2 தானே, அப்போ இன்னும் ஸ்டேபிளாக இருக்கும். ஸோ நீ வேறு உனக்கு வேணுமா எடுத்துக்கோ சொல்லிட்டு எலக்ட்ரான்ஸ் கொடுப்பா. அதனால லீஸ்ட் beryllium, then carbon, then boron, nitrogen, fluorine, oxygen, neon and lithium. Lithium means why second for the lithium means 1s2 height. Hello everyone, எப்படி இருக்கீங்க எல்லாரும்? All good? So இன்னைக்கு நாம எந்த டாப்பிக்கை பற்றி படிக்க போகிறோன்னா 11th ஸ்டாண்டர்ட் கெமிஸ்ட்ரியில் பீரியாடிக் ப்ராப்பர்ட்டிஸ் அண்ட் கிளாசிஃபிகேஷன் ஆஃப் எலிமெண்ட்ஸை பற்றி தான் நம்ம டிஸ்கஸ் பண்ண போகிறோம். திஸ் இஸ் எ வெரி ஸ்மால் சாப்டர், ஒரு சின்ன சாப்டர் தான். பட் தேர் ஆஸ் அ லாட் ஆஃப் எக்ஸெப்ஷன்ஸ் திங்ஸ், தேர் ஆர்ஸ் அ லாட் ஆஃப் வேரியேஷன்ஸ் ஹேப்பனிங் இன் திஸ் சாப்டர். ஸோ அதனால் இந்த சாப்டர் பேஸ் பண்ணி தான் நமக்கு வந்து பி பிளாக்காக இருந்தாலும் டிஎன்எஃப் பிளாக்ஸாக இருந்தாலும் நிறைய விஷயங்கள் இந்த சாப்டர்லேருந்து நமக்கு படிக்கலாம். Okay, so this is like we are going to discuss about all the important topics of this particular classification of elements and the periodicity in their properties. So one more thing, இது வந்து இந்த chapter வந்து not only the NEET based, it also based on the CBSE board also. CBSE board based பண்ணி தான் இந்த chapter. Okay, so in the chapter I have prepared in such a way that they can NEET students also can watch it, even the CBSE students also can watch it. Okay, shall we go to the chapter? So basically we are going to look into the classification. First of all, we are going to look to the classification. What do you mean by the classification? Classification சொன்னா என்னது? நமக்கு ஒரு thing, இப்போ classification usually நம்ம நார்மலி நம்ம சொல்றேன்னா ஆர்கனைசிங் ஒரு திங்ஸை நம்மக்கிட்ட இருக்கிற நிறைய திங்ஸை வந்து ஆர்கனைஸ் பண்ணுறது தான் கிளாசிஃபிகேஷன் சொல்கிறது. ஆமாம் தானே? ரைட். ஸோ கிளாசிஃபிகேஷன் நம்ம ஏன் பண்ணுறேன்னா நமக்கு ஒரு சிஸ்டமேட்டிக் அரேஞ்ச்மெண்ட் வேணும். ஒரு பர்டிகுலர் மெட்டீரியலுக்கோ ஒரு பர்டிகுலர் சப்ஸ்டன்ஸுக்கோ சிஸ்டமேட்டிக் அரேஞ்ச்மெண்ட்ஸ் இருக்கும்போது தான் கிளாசிஃபிகேஷன் நடக்கும். ஸோ வாட் இஸ் த நீட் ஆஃப் கிளாசிஃபிகேஷன் மீன்ஸ் அதோட ஒரு ஆர்டர் கிடைக்கிறதுக்கு. நம்ம வந்து நம்ம கிச்சனில் வந்து we will be classifying the spoons differently, plates differently, glass differently, right? அது ஏன் நம்ம பண்ணுறாங்க? டம்ளர் டிஃப்ரெண்ட்டாக நம்ம கிளாஸிஃபை பண்ணி வைப்பாங்க. இதுலேயே வந்து கிளாஸ் டம்ளர் டிஃப்ரெண்ட்டாக இருக்கும், பிளேட்ஸ் டிஃப்ரெண்ட்டாக இருக்கும். நம்ம வந்து நமக்கு ஈஸிலி அதோட ப்ராப்பர்ட்டிஸ் தெரியும், ஈஸிலி அதோட யூஸ் தெரியும், நமக்கு ஈஸிலி அது வந்து எடுக்க முடியும். கரெக்ட்? ஸோ தட் இஸ் த நீட் ஆஃப் த கிளாசிஃபிகேஷன் இன் ஆர்டர் ஃபார் தி சிஸ்டமேட்டிக் வேஸ் ஆஃப் அரேஞ்சிங் த பர்டிகுலர் ஆர் ஆர்கனைசிங் த பர்டிகுலர் ஒன் ஆர் ஆர்கனைசிங். இனி எலிமெண்ட்ஸை பற்றி சொல்லும்போது we can say that systematic ways of arranging and organizing and studying the properties of the elements. அது இன்னும் ஈஸி ஆகிறதுக்கு தான் we are doing this particular classification. Okay, so properties of the elements will be while doing this particular classification we can say that for example in the kitchen itself I told you நம்ம வந்து classification பண்ணும்போது ஒரு ஸ்டீல் பிளேட்ஸ் எல்லாமே ஒரு இடத்துல வைக்கிறேன்னா நமக்கு தெரியும். Okay, these are the steel plates, these are the things, right? ஸோ நமக்கு அதோட ப்ராப்பர்ட்டிஸ் தெரியும். ஸோ அதே மாதிரி தான் the properties of an element will be repeating themselves after the regular intervals. ஸோ ஒரு எலமெண்டோட ப்ராப்பர்ட்டி வந்து it will be repeating after regular intervals. So this is the main point why we need the classification. Now periodic classification இருக்கிற எலமெண்ட்ஸை வந்து கிளாசிஃபிகேஷன் பண்ணுறது ரொம்ப நாளுக்கு முன்னாடியே ஆரம்பிச்சிட்டாங்க. They have started very long before and it was started from this particular Dobbernier triads and then it is gone to the Newland law of octaves. Then they have done with the Mendeleev periodic table and modern periodic table. As of now we are accepting this particular one and we are following this modern periodic law, but it started from the Dobbernier triads and now it's ended in the particular modern periodic table. Clear? So இதில் இருக்கிற நாலுமே நம்ம டிஸ்கஸ் பண்ணி அதில் இருக்கிற என்னெல்லாம் ப்ராப்பர்ட்டிஸ் இருக்குன்னு எல்லாமே இந்த கிளாஸில் நம்ம டிஸ்கஸ் பண்ண போகிறோம். Next one is the Dobbernier law of triads. So this is actually like இது acceptable இல்லை. அந்த டைம்லேயே வந்து like they have just rejected this law because it was only acceptable for very few elements only. எப்படி சொல்கிறாங்கன்னா ஒரு 3 எலிமெண்ட்ஸுக்கு நம்ம இப்போ எப்படி சொல்கிறோம், ஒரு அட்டாமிக் மாஸ் இன்க்ரீஸ் ஆர்டரில் அட்டாமிக் மாஸ், this is very important children, அட்டாமிக் மாஸ் இன்க்ரீசிங் ஆர்டரில் ஒரு எலிமெண்ட்ஸ் அரேஞ்ச் பண்ணும்போது ஃபர்ஸ்ட் எலிமெண்டோட அட்டாமிக் மாஸும் செகண்ட் எலிமெண்டோட அட்டாமிக் மாஸும் ஆட் பண்ணி by 2 பண்ணி middle element or atomic mass கிடைக்கும். For example, you have lithium, you can see, I hope you can see this, lithium, sodium and potassium is there. Atomic mass of lithium is 27 and the potassium is 23 and the sodium is 23 and the potassium is 39. Okay, so when we just add this particular mean of this atomic mass of first and one, which means lithium and the potassium, choose some other color. Lithium and the potassium, we will get the atomic number of this particular sodium. So 7 plus 39 divided by 2, which is equal to 23. That is the atomic number of this sodium. So this was the this was the discovery which was done by the Daubeney. But again, it was not acceptable for every elements. So this is not seem to be work only for a few elements. So it was dismissed. Since it was not used for all the elements, it was just dismissed. Clear? So this was the first classification which was done for the periodic or elements. We can say that. Then comes our Newland's law of octaves. Octaves means itself is 8. So what he is telling now, he is also arranged everything was in the mean of atomic masses. Atomic mass base பண்ணி தான் எல்லாமே நடக்குது. ஒரு செகண்ட். What is happening? Atomic mass base பண்ணி தான் atomic mass base பண்ணி தான் எல்லாமே நடக்குது. எது அந்த டாபனியர் இருந்தாலும் this Newland's law of octaves இருந்தாலும் whatever it is happening on the basis of the atomic mass. And this is very very important. You have to know it. Okay, you have to make a note of this also. Always all the laws and all the laws which we are அந்த stepping stone இருக்கிறது எல்லாமே atomic mass base பண்ணி தான் இருந்தது. Okay, now properties of every eighth element are similar to the first element. Every eighth element or every first element will be having the same properties of the eighth. Just like that particular sa, ri, ga, ma, pa, dha, ni, sa. Correct? Sa is starting from the 1 and again we are getting the sa at the eighth one. Sa, ri, ga, ma, pa, da, ni, sa. First one and eighth one again we are getting the sa only, right? Just like that, first one and eighth one will be having the same property. See, this is the first one here. Correct? This is the first one here. I will choose some other color. One second. Okay. This is the first one here. So while we are checking this 1, 2, 3, 4, 5, 6, 7, 8. Again, this is having the same property. So lithium, in our modern periodic table also we can say that lithium and sodium having the same property. Am I correct? And of course beryllium and the magnesium is having same property, because from the beryllium we have to start it from the 1. From the beryllium we are starting the 1 means 1, 2, 3, 4, 5, 6, 7, 8. When 1, 2, 3, 4, 5, 6, 7, 8. So from the beryllium one, then the 8th will be magnesium. Here boron, aluminium and carbon and silicon. So this was done by the Newland's law of octaves. So Newland's law of octaves, they are telling like when the elements are arranging in the increasing order of their atomic mass, every first element and eighth elements will be having the property, like they will be having the same property, which is actually true in the modern periodic law also, because you can see that the lithium and this particular sodium is comes under the category of same group, and the beryllium and this magnesium also. So we can see that that is actually true. But what happens here is the drawback of this particular Newland's law of octaves is they are actually obeyed till calcium only. After calcium, calciumக்கு அப்புறம் என்ன ஆயிடுச்சுன்னா they are not allowing or they are not obeying this particular rule. None of the elements after the calcium is not obeying this rule. இந்த ரூலை வந்து யாருமே வந்து calciumக்கு அப்புறம் இருக்கிற எந்த elementsமே this rule is not obeying. So this was the major drawback of this particular Newland law of octaves. See, applicable only up to calcium. This was the major drawback. This was the major drawback of this particular Newland's law of octaves. Next one is the mentally periodic table. So periodic table la வந்து contributions பாக்கும்போது first triads வந்தது, அதுக்கப்புறம் octaves வந்தது, அதுக்கப்புறம் தான் mentally periodic table வந்தது. அது வந்து like it was actually widely accepted because there was a lot of merits and there was lot of demerits also was there. Of course it will be, but நிறைய merits இருந்தது. மிச்சம் இருக்கிற laws எல்லாம் considered பண்ணும்போது there were lot of merits, and this law, the law which is come from the Mendeleev or the law which was proposed by the Mendeleev, அது வந்து most of the elements was actually following that. So it was widely accepted when compared to the other two laws which we already discussed. அது டிஸ்கஸ் பண்ணும்போது அதில் அந்த ஒரு லாஸை நம்ம கம்பேர் பண்ணும்போது இந்த law வந்து widely accepted-ஆக இருந்தது. But they were having some problems. They were having some demerits also. We will discuss that. Okay. So what he has done is he arranged all the 63 non-elements in the increasing order of the atomic mass or weight. Again, he is doing the same mistake which that time they were not knowing about it. அவங்களுக்கு அந்த டைமில் வந்து அட்டாமிக் வெயிட் இல்லைன்னா அட்டாமிக் மாஸ் இல்லை, வேறு ஏதோ தான் அதோட ப்ராப்பர்ட்டிஸ் எல்லாமே டிட்டர்மைன் பண்ணுறதுன்னு அவனுக்கு தெரியாமல் they were doing the same mistake, that is atomic weight or atomic mass. They were arranged on the increasing order of their atomic mass. And what happens means he can say that the elements with the similar properties occupies in the vertical column, occupies in the same vertical column. Same vertical column means same vertical columns was there, horizontal columns were there. This is vertical and this is horizontal. Okay, so the vertical columns was known as group. What was vertical column? Vertical column is this, horizontal column is this. So vertical columns was called as the group, and there were almost 8 group at that time. Okay, 8 groups at that time. And the horizontal rows. Okay, did I tell you horizontal rows? Okay, horizontal columns இல்லை, vertical column, horizontal rows இப்படி இருக்கிறது. ஸ்லீப்பிங் பொசிஷனில் இருக்கிறது horizontal, ஸ்டாண்டிங் பொசிஷனில் இருக்கிறது vertical. அப்படி யோசிச்சா போகுது. ஸ்டாண்டிங் பொசிஷனில் இருக்கிறது vertical, ஸ்லீப்பிங் பொசிஷனில் இருக்கிறது horizontal. So horizontal rows are called as the period, and there were almost 7 periods during that time. Okay, so this was he was telling that all the elements or the elements which have the similar properties I have arranged in the vertical columns, and there were 8 vertical columns, and the vertical columns are called as the group. Clear everyone? Clear? Okay. Now what happens means, first of all, what are the postulates or what are the characteristics of the mentally periodic table is, he told that physical and the chemical properties of the elements are the periodic function of their atomic mass. This is very, very important. What it is? Periodic function of their atomic mass. அவங்களோட atomic mass ஓட periodic function. Periodic function means it is repeating. Okay, periodic function of their atomic mass. This is the first and foremost characteristics of the mentally periodic table. And what was another characteristics or what was another merit means, you know that after the aluminium, you know that now it is silicon, now it is gallium, and after the after the silicon, you know that now it's germanium, right? But அந்த டைமில் இந்த ஒரு gallium சொல்கிறதும் அதே மாதிரி ஜெர்மேனியம் சொல்கிற எலமெண்ட்ஸையோ they didn't find it out, but he actually give the name for that element, and he told that okay, this element is going to find out that time. Now அந்த எலமெண்டோட ப்ராப்பர்ட்டி நான் இப்போ சொல்ல முடியும், அந்த எலமெண்ட் வந்து நான் கையில் வச்சுட்டேன்னா உருகி போயிடும், அப்படிதான் அவங்களோட மெல்டிங் பாயிண்ட் இருக்கும். ஸோ he actually told that this is the properties of that element, and that element is going to discover on future, and he is named as gallium as eka aluminium. This is very important. It will be asking in the questions also, what is the another name of gallium. This is very important. And germanium for the eka silicon. Okay, it's very important, children, note it down. It's very, very important. Okay. Now now next one more thing is atomic mass of this particular beryllium. Now that was also corrected. So earlier it was wrong, and the atomic mass of this beryllium also was corrected, and this was also another merits of the mentally periodic table. Clear? So this was all the characteristics or the merits of the mentally periodic table. Now drawbacks. We know that whatever we done or whatever is the நம்ம என்னதான் கண்டுபிடிச்சாலும் அதற்கு ஒரு சைடு நல்ல சைடு இருக்கும், ஒரு கெட்ட சைடு இருக்கும். ஸோ திஸ் வாஸ் அ மெரிட்ஸ் ஆஃப் த mentally periodic table. Now coming to the demerit of the mentally periodic table is hydrogen does not have a fixed position. Actually இது இப்போவும் ஒரு பிரச்சனையில தான் போயிட்டு இருக்கு. இப்போவும் வந்து ஹைட்ரஜனுக்கு வந்து ஒரு ஃபிக்ஸ்டு பொசிஷன் சொல்ல முடியாது. ஸோ ஹைட்ரஜன் இஸ் நாட் ஹேவிங் a fixed position. That is the first and most important demerit of the mentally periodic table. And of course there is no regular trend. This is another point. He told that I'm arranging everything in the increasing order of the atomic mass. Hey, I'm arranging everything in the increasing order of the atomic mass. This is all the elements which is known at that time. I will be arranging on the increasing order of the atomic mass. But what happens actually means there was no regular trend. There was அங்க இங்க ஏதோ தப்பு நடக்கு. அவங்க வந்து சரி இது கரெக்ட் இல்லையா, இந்த ஆர்டர்ல இது கரெக்ட் இல்லையா, சரி நான் அதோட அட்டாமிக் மாஸ் வந்து நான் கரெக்ட் பண்ணிட்டு நான் எழுதிக்கிறேன் சொல்லிட்டு சில எலிமெண்ட்ஸோட எல்லாம் அட்டாமிக் மாஸ் வந்து ஈவன் தோ தட் இஸ் ராங், கரெக்டான அட்டாமிக் மாஸ் தான் இருந்தது. he corrected it. He corrected and like he make it into incorrect, and in order to suit in that particular particular groupல வந்து அது வந்து ஃபிக்ஸ் ஆகிறதுக்காக he just corrected, he just like correctana and the atomic mass he just incorrected and he just put it in that particular group. Okay, so there was no regular trend on this particular order of atomic mass. And next one, isotopes. You know that isotopes is like there was like they was not having a fixed position on this particular mentally periodic table. They were not having a fixed position on the mentally periodic table. Next one is now comes the modern periodic table. Modern periodic law இல்லனா modern அது வந்து எப்படி அது வந்து what is, it was actually found out by the Moseley periodic table. So it was actually they are telling like Moseley was invented and he told that the atomic mass concept itself is wrong. The periodic and the physical and the chemical properties of an element is a periodic function of their atomic number. This is a very very most important theory, or this is a very very most important postulate he was telling, or the idea he was giving. It's not about the atomic mass, it is nothing about the atomic mass, it's all about depends upon the atomic number. I repeat, the physical and the chemical properties of an element, the physical and the chemical properties of the elements are the periodic function of their atomic number. So this was the modern periodic law. And in the modern periodic law also there will be repetition of the properties of this particular elements at a regular interval when they are arranging in the increasing order of their atomic number. See, earlier in the other all laws, that is Mendeleev and all these persons, now in that laws and all we discussed like there is something they are also arranging in the increasing order only, but it was all about the atomic mass. அட்டாமிக் மாஸை பேஸ் பண்ணி தான் எல்லாமே இருந்தது. ஆனால் இதில் என்ன ஆயிடுச்சுன்னா எல்லாமே அட்டாமிக் நம்பர் எல்லாமே இன்க்ரீசிங் ஆர்டரில் தான் வரணும், எல்லாமே கரெக்ட் தான், ரெகுலர் இன்டர்வல் டைமில் தேர் ப்ராப்பர்ட்டி இஸ் ரிப்பீட்டிங், பட் இட்ஸ் ஆல் டிபெண்ட்ஸ் அப்பான் தி atomic number. Okay, now periodic law is the consequence of the periodic variation in the electronic configuration. So there is something which is called as the electronic configuration, which we can find it out by the periodic, or which we can find it out from this atomic number, and that is the reason why this particular periodic or this particular periodic function is happening, or periodic variation is happening. It all depends upon the, or it's also happening in the electronic configuration, due to electronic configuration. So other base பண்ணி நமக்கு இருக்கிறது தான் மாடர்ன் பீரியாடிக் லா சொல்கிறது. ஸோ த மாடர்ன் பீரியாடிக் லா ஆல் வாஸ் லைக் இந்த ஒரு ஐடியா வச்சு தான் இன்க்ரீசிங் ஆர்டர் ஆஃப் தியர் அட்டாமிக் நம்பர். ஹைட்ரஜன்லேருந்து ஸ்டார்ட் ஆகுது. ஹைட்ரஜன், ஹீலியம், லித்தியம், பெர்லியம், போரான், கார்பன், நைட்ரஜன், ஆக்சிஜன், ஃப்ளோரின், நியான், சோடியம், மெக்னீஷியம், அலுமினியம், சிலிக்கன், பாஸ்பரஸ், சல்ஃபர், குளோரின், ஆர்கன், அப்படி லைக் இட் வில் பி கோயிங் லைக் திஸ். Okay, and now we are going to study in depth about all these things. Clear? Okay. So modern periodic lawsல periods இருக்கு. Periods is actually just like in the அங்க இருந்த மாதிரி தான் mentally periodic tableல இருக்கிற மாதிரி தான் ஹொரிசாண்டலா இருக்கிறது, படுத்துட்டு இருக்கிறது. horizontal rows are called as the periods, and there are actually 7 periods in this, and elements belongs to the same period have same valence shell. What do you mean by the valence shell, children? What do you mean by valence shell? Valence shell is the outermost shell of an atom. ஒரு ஆட்டத்துக்குள்ள இருக்கிற outermost shell தான் valence shell சொல்றது. For example, இது ஃபர்ஸ்ட் ஷெல், this is the second shell, and this is the third shell. Okay, these are the 3 shells, and in that this particular shell is called as the valence shell. This is the valence shell. Are you getting my point? So this is the valence shell, and the valence shell means we can say that the periods are the one which belongs to the same, see the elements which is belongs to the same period, they have the same valence shell. So they are valence, எதெல்லாம் சேம் பீரியட் இருக்கோ அதுக்கு எல்லாத்துக்குமே வேலன்ஸ் ஷெல் சேமாக தான் இருக்கும். எப்படின்னா ஃபார் எக்ஸாம்பிள் ஹியர் சி லிதியம் பெர்லியம் போரான், சி லிதியத்தோடது லிதியம் சொல்கிறது 1s2 2s1, beryllium is 1s2 2s2. Am I correct? Am I correct? Now coming to boron, 1s2 2s2 2p1. So the valence shell we are checking, the valence shell is basically this is the first shell or this is the first shell. I'm not telling about the subshell actually, valence shell, just shell. So this is the first shell and this is these two belongs to the second shell, right? S and P is in the second shell, L shell. So there are L shell here, so that's why they belongs to the second period. Are you getting my point? So lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon and all, they will be having two second shell. That is two shells only, K and L only. So that's why they belongs to the same shell. Okay, that's what he is saying. The elements belongs to the same period. They will be having the same valence shell. So those second shell was having like lithium, beryllium, from the lithium to neon, they will be having the same valence shell. Valence shell, that is not the subshell. Valence shell, that is L shell. For this particular one, I'm telling you. Okay. Next one is the group. Group is the one group are the one which is the vertical columns which is in your periodic table. This is the groups. These are the groups. Okay, and these are the periods. These are the groups. All these are the groups. This all are the groups. So vertical vertical columns are called as the groups, and they were talked together 18 groups. It's been found out more together 18 groups, and the elements of the same group have similar valence shell electronic configuration. They have the same valence shell electronic configuration. I'll tell you. See, for example, this lithium, sodium, potassium, rubidium, cesium and all, they will always have the valence shell 1. For example, sodium atomic number is 11, 1s2, 2s2, 2p6, 3s1, 6, 11. Correct? So they will be always this is one. This is also 1. So they will be having the electrons 1. Are you getting my point? So they will be having the same same valence shell electronic configuration. So if it is the first group means they will be always have the 1 is the valence shell electron. Second one will be having 2 will be the valence shell electrons number. Okay, this was the valence shell. Now, based on their type of the orbitals, you have studied about the orbitals. If not, you will be studying in the atomic structure also. Orbitals, there are different bases on the basis of the orbitals. You know that there are atomic orbitals where the probability of the finding the atoms at the maximum. Correct? In the shell, there are some orbitals also, subshell also, S, P, D, F and all. So on the basis of that, we have the S block elements. We have the S block. S block, P block, D block and F block. What are the fun? S block, P block, D block and the F block elements. So in that there is some exceptions, which is this particular hydrogen is placed outside the periodic table, though it has a last electron in the S orbital. See, it is having 1s1 only, but it is just considered as like outside of the periodic table, even though they have the S orbital, S orbital, last electron in the S orbital. And helium, there is another exception, belongs to the helium. It belongs to the S block. 1s2, 2s2 is the hydrogen, helium. 1s2, 2s2 is the electronic configuration, and they belong to the S block. But we have arranged them in this corner. Okay, not in this corner. Okay, so these are the two exceptions which you have to note down here. So hydrogen and helium, so based on their elements or based on the electrons which is falling into the particular block, they are belongs into the S block, P block, D block and F block. We are classifying them into the S, P, D and F. Now first one is this one. These two are considered as the S block elements. These two, this lithium, sodium, potassium, rubidium, cesium, francium and beryllium, magnesium, calcium, strontium, barium, radium. These are the two ones. These are the two ones which comes under the category of comes under the category of S block elements. These are the two ones which comes under the category of the S block elements. In that itself, like they are also this particular one. One more thing is there, children. This one, which one's this? Lithium, sodium, potassium, rubidium, cesium, francium and all. This particular one, that is first group one is actually called as alkali metals. And the second group elements, which is beryllium, magnesium, calcium, strontium, barium and all, they are called as alkaline earth metals. These two belongs to the S block elements, because the last electrons in this particular both this particular groups, they belongs to the S subshell only. So that's why they comes under the category of the S block elements. I hope this is clear. Now S block elements, as I told you, the last electrons will be entered to the N subshell. N subshell means NS subshell whatever it is. For example, here, see here lithium is there, lithium 1s2 2s2, lithium, hydrogen, helium, lithium, right? 1s2 2s2, this is lithium, correct? So this is lithium and that also belongs to these particular S blocks, and sodium is 1s2 2s2 2p6 3s1. This is 1s2 2s1, okay, not 2s2 2s1. So this is actually belongs to this category, which is they will be having the S. Outermost electrons will be going to the S block la poirupanga. Ipo lithium consider பண்ணும்போது lithium atomic number is 3, so 1s2 2s1 வரும், அது S ல தான் வந்துருச்சு, ஆமா தானே? Now helium இந்த consider தான் வரணும், 1s2 தான் வருது, correct? Helium also 1s2 தான் வருது, but that is another exception case which we have discussed. அது இந்த ஒரு சைடுல தான் அதுக்கு இடம் கொடுத்திருக்காங்க, ஆமா தானே? Now here sodium, நம்ம sodium consider பண்ணும்போது 1s2 2s2 2p6 3s1, right? Atomic number of sodium is 11, so 1s2 2s2 2p6 3s1, so that is also S only. So it can be whatever it is. See, for example, in the considering this particular lithium, lithium 3 1s2 2s1, sodium is 11 1s2 2s2 2p6 3s1. Am I correct? So this N can be anything. It can be 2 3 4 according to the period, right? According to the subshell, according to the shell which they are entering, but this particular block are same. Blocks are same, even the blocks are same, and what else is same? The blocks are same and also the electrons number is also same. So that's why they are considering as NS. That's why it is written here as NS subshell. Next one is the outermost electron configuration is NS 1 to 2. It can be 1 for the lithium, sodium, potassium, rubidium, cesium, francium and all. 2 for beryllium, magnesium, calcium, barium, strontium, barium, strontium and all. They will be having 2. So it can be the electronic configuration can be 1 either 2, ns1 to 2 is the correct. This particular hyphen means 1 to 2. It can be 1 or it can be 2 because the maximum number of electrons which can accommodate in the s block element s subshell is 2 only. Okay, now group 1 to 2 are all metals. They are all metals. This is another peculiarity. They are all metals. Next one, so group 1 and 2, they are also called as I told you, alkali metals are also called as group 1 elements, and the alkali group 2 is called as alkali earth metals. So outermost electronic configuration will be ns1 for this, and this will be ns2. Clear? This is we have already discussed about the s block elements. Now comes to the p block elements. P block elements is actually, s block elements was this side of this periodic table. P block elements are this side of the periodic table. So they contains the metals, non-metals and metalloids, and they also have the noble gases also. Okay, they have some metals, some non-metals, some metalloids, and they have the noble gases also. It's a mixture actually. And now, as I told you, see, block means last electron எந்த சப்ஷெல்ல போகுதோ அது அதோட block. ஆமா தானே? இப்போ லாஸ்ட் எலக்ட்ரான் எஸ்ல போகிறேன்னா அந்த பர்டிகுலர் எலிமெண்ட்ஸ் இஸ் கன்சிடர்ட் as the s block elements. லாஸ்ட் எலக்ட்ரான் வந்து pல போறேன்னா அந்த பர்டிகுலர் element will be considered as the p block elements. So here also the same scenario is happening. Last electrons is entered to the np subshell. Last electron is considered or it is entered to the np subshell. And from group 13 to 18 is indicate some metals, all non-metals and metalloids. They can be, there are metals are there, non-metals are there, metalloids are also there. In the 13 to 18 is the p block elements. This is also another important point. 13 to 18 in the group. Okay, in the group 13 to 18 is the p block elements. So outer electronic configuration is ns1, ns2, np126. So for example, oxygen. Okay, for example, I am giving you an oxygen. 8, 1s2, 2s2, 2p6, no 2p6. 2p4. This is the electronic configuration of the oxygen, right? So here after filling this particular one, this s only, they are going to the p. Correct? S block s elements fill ஆனதுக்கு அப்புறம் தான் p block லேக்கு elements போகும். So what is happening here is we can say this as ns2 is completely filled, then they are using this particular np4. Here specifically 4 means it's because of the oxygen. It can be 1 to 6. np, the p orbital can be accommodate 6 electron till 6 electron. So ns2 np 1 to 6 is possible. See, 13th group is actually called as the boron family. It considered of it is the boron family, and 14th group is carbon family. 15th is nitrogens, or we can nitrogens also we can call as nitrogen family. 16th one is chalcogens. 17th one is halogens, and this one is the 18th one is the noble gases. See here. Boron, carbon, nitrogen, oxygen, fluorine, neon. I mean noble gases. Boron family, carbon family, nitrogen family, oxygen family, halogen family, and noble gases. This is another name of the particular nitrogen family, and in this particular oxygen families and all. This are important. You can expect question from this. This is also important. This is also important. Okay. Now comes the D block elements. D block elements, these are the D block elements. D block elements, as I told you in the S and P, whichever is the element, last electron வந்து D subshell போகிறேன்னா அந்த elements தான் என்ன சொல்றது? D block elements சொல்றது. So last electrons, and you know what is electronic configuration also. நம்ம எப்படி electronic configuration எழுதுவோம்னா 1s, 2s, 2p, 3s, 3p இதெல்லாமே fill ஆனாலும் 3D fill ஆகாம we will be going to the 4s. Am I correct? Then only we will be coming back and filling the 3D because of their energy difference, right? You have studied that in atomic structure. So n-1 into D subshell means this one is considered as the n, and when we are considering this particular one, this is n-1. So they are considering this particular one as n, then it is n-1 now. It is this 4 is equal to n means n-1 is 3. So n-1d subshell, they are going to the n-1d subshell, and the outer electronic configuration is n minus 1d 1 to 10, n is 0 to 2. Here you have to note another one more thing. N minus 1d 1 to 10 means this one is actually the n 4. So just less than that, penultimate just less than that is n minus 1. Here n is 0 to 2. Why ma'am 0 to 2? ns means it won't be 0 to 2 na, it's 1 to 2 na. No, there are some elements which will be having, they won't be filling into this. There are some exception cases where they won't be filling into the s orbital. Instead of that, they have to fill into the 4s or 5s or whatever it is before going to the d orbital, penultimate shell. But they won't be doing that in order to get the stability. For example, chromium and copper and all you have studied, like chromium is 24 and copper is 29. In order to get the stability, they will be like 4s1 and 3d4 or 3d5, then 4s1 and 3d10. Correct? So that is happening, and that is why they are giving their outermost electronic configuration is 0 to 2. Okay, groups are from 3 to 12 and all are metals. They are 3 to 12 and they are all metals also. Clear? Now D block elements, first one is the 3D series, which is scandium to zinc. 30. Then 4D series is yttrium to cadmium. 5D series is, then comes the 6D series. Correct? These are the one. So you have to get an idea about this 3D, 4D, 5D. These are very important one, which will be, there is a lot of exception when coming to the atomic radius, ionic radius, and this electronic ionization energy and all. Okay. So this is all about the D block elements. Now, zinc, cadmium, one more thing, zinc, cadmium and mercury are most transition elements because they do not have partially filled d orbitals in the neutral or any stable oxidation state. Since they do not have any partially filled orbitals, they are the transition. They are not considered as the transition elements. So this is an exceptions, and this is our F block elements. That is this is the two particular period of the F block elements, and here the last electron filling will be done on the n-2 F subshell, because n will be on the n will be considered as S, n-1 will be D, n-2 will be the F. The outermost electronic configuration will be the n-2 F 1 to 14, because F can accommodate maximum electrons of 14, n-1 ns. So this is considered as the first one, then this n-1 and this n-2. Group 3 and all are, they are all metals. So F block is that there are lanthanoids and actinides. Lanthanoids means they are also called as the first inner transition series. They are called as second inner transition series. They are forming Ce to Lu and Th to Lr. Okay. Now, elements after the uranium in the periodic table are called as transuranic elements. Element after the uranium in the F block elements. In the F block elements in the periodic table, they are called as the transuranic elements. This is an extra point. Okay. Now, S block, one more thing. Representative elements, transition elements, inner transition elements and all you will be needing, like this are all like extra points, extra shoots, extra points. Okay. So, S block elements along with the P block element. When S block elements and P block elements together, they are called as the representative elements. Next one is the elements which have partially filled d orbitals and neutral state or any stable oxidation state. The elements which is having partially filled neutral state, partially filled orbitals which is in neutral state or in oxidation state, if they have the partially filled one, they are called as transition element. Zinc, cadmium and mercury is an exception from that. Okay. Now elements in which all the three shells, that is n, n-1, n-2 subshells are incomplete. If they are incomplete means they are called as inner transition elements. In all this particular three shells, n, n-1, n-2, if they are incomplete means they are called as inner transition elements. So atomic number of noble gases. Now comes this is another point also, you have to remember the noble gases and the atomic number. Helium is the first one. Helium. Helium, neon, argon, krypton, xenon, radon. These are the one which belongs to the particular atomic number. And 2, 10, 18 noble gases, these are the noble gases and these are the atomic number. See, you can add here. See, plus 8 is equal to 10. 10 plus 8 is 18. 18 plus 8 is equal to 36. 36 plus 8. No. This not belongs here. Okay, so these are the particular number or atomic number of the noble gases. Clear, everyone? Clear? Okay. Next one is, how are the elements named in the periodic table? So the elements, how they, you know that some elements are based on their Latin name, some elements are giving the tribute to the particular scientist, some elements are giving like in the name, name of the scientist, some elements will be like where they were found out, discovered. Right, in the place la avanga discover pannirukanga, adha base pannittu namakku vandu elements vandu we can classify them, right? We can classify how these elements are actually, you did not classify how the elements are actually got their particular name in the periodic table. So maybe on the name of the scientist, maybe based on the name like planets or Greek mythology, maybe on the place they discovered, and maybe how they are like, how they behave. Correct, elements with its behavior, right? Now IUPAC name or nomenclature of the elements which is more than atomic number more than 100, 101, 102 and all. So how that we will be giving. So always remember that we have to roots are put together in order of the digit from 0 to 9, which makes the atomic number. I'll tell you, IUM is added at the end and corresponding symbol has 3 letters. For example, see, these are the names, okay? So for example, if we are taking that 105, that is a, I'll give you an example here, Z105, okay? 1 means it is UN, am I correct? 1 means UN, 0 means it is nil, 5 means it is pent, and extra we have to add at the end. What we have to add? We have to add IUM at the end. So IUM. So this will be the name of 105 and this is actually called as, see, U for nil, N 5P. So the short form UNP. This is capital letter UNP. I hope this is clear. Okay, now finding the position of an element in the periodic table. Okay, so how to find the periodic table or how to find the elements in the periodic table, the position, the correct position. Okay, write the electronic configuration, subshell electronic configuration, we have to write it, write the electronic configuration, and we have to check the subshell in which the last electrons enter is the block. I told you S block, P block and D block, wherever is the last electron goes in that particular subshell, that is the block and block. For example, 1s2, 2s2, 2p4, this is the electronic configuration, and from this you can understand that this particular one, here in the P block it is happening, in the P block this particular element is belongs to, because the last electron is filled in the P. Am I correct? Now next one, how to find the group. Now you got to know that, okay, this how to find the block actually, okay, S block or P block or whatever it is. Now to find the group, okay, which is the first group or second group or 14th group or 15th group and all. For the S block, if the elements, see, first of all you have to know which particular block that particular element is element belongs to. உங்களுக்கு ஒரு element கொடுக்கும்போது அந்த elementோட atomic number கண்டிப்பா கொடுப்பாங்க, இல்லைன்னா electronic configuration கொடுப்பாங்க. இதில் ஏதாவது ஒன்று கொடுப்பாங்க. atomic number கொடுத்துட்டேன்னா you have to write down the electronic configuration. Electronic configuration, subshell electronic configuration கொடுக்குறேன்னா it's moreover easy. So what we have to look, you have to look whether that particular last electron gone, that electron, whichever is the block, whichever is the subshell that electron gone, it will be the block. So if it is an S block element, we can consider the particular group as the number of electrons in the outermost S orbital. For example, S orbital, you know that it can be 1 and it can be 2, maximum 1 or 2, because the maximum number of electrons which can be accumulated in this orbital is 2. So either it can be 1 or either it can be 2. If it is 1 means the group number will be 1, it is 2 means the group number will be 2. As simple as that for the s orbital. I repeat one more time. So if the particular elements belongs to the s block, okay, you know that how many electrons are filling in the s block, which will be s orbital, it will be 2. So either there is a 2 possibility, ns1 or ns2. So if it is ns1 means that will be comes to the group number of first group. 2 means it will be on the second group. As simple as that. Now p block elements. P block elements are the number of electrons in the outermost shell plus 10. For example, you have 1s2, 2s2, 2p4. Okay, so this is actually block is p block element. Now coming to this particular group, for the elements which is specifically in the p block only, this is the outermost electrons. This is the outermost shell, P subshell, and this is the outermost electron. How many electrons are there in that shell? 4. 4 plus you have to add the constant 10. So this belongs to 14th group. Or you can do another way also. You can just add both the electrons. The electrons which is in the subshell, which is the electrons which is in the 2s2 and 2p4. S and P you can add, which will be total 6. And okay, that is not required. You can do, wait a second, it should be 12. Okay, here they are giving it like the, okay, they are here considering like they are adding all the 2 electrons, 4 plus 2. So this is the outermost shell now, second shell. So you can add the both the 2. So 6 it will be plus 10, it will be 16. Or else you can just consider this only, this particular p block element, the p block electrons only, those that will be actually 4, but you have to add 12 into this. So then also you will be getting 16. This is also in a way, this is also a way. This is the way that I have tell you, like number of electrons in the outermost shell. Outermost shell means there are 2s2 and 2p4 you have to consider. So 6 it will be 6 plus 10, 16. Or you can do that, just take this particular p block. How many electrons are there in the p orbital, and you can add 12 also. Instead of the 10 you can add 12 and you can get the group number. Next one is the D block elements. D block elements is the, how to find it, the number of electrons in the outermost shell plus the penultimate D subshell. You have to calculate all the one. 4s2 3d5 means you have to add both this, 4s2 also, 3d also. Then only you will be getting the group number. 4s2 3d5 means it will be 4s2 3d5 means 5. That is also will be there. Now, one second. Okay, we have done with this. Okay. Now find the group number, which is a group when there is Z is greater than 100. If they are giving you Z is greater than 100 means you can just cut short into, or you can just write it as Z is equal to 100 plus X. So 100 plus X means they have already given you the Z is equal to 103. So it can be written as 100 plus 3. So the X is equal to 3 and X is equal to the group number. So we can find out the group number like this. Group number. This is in another easiest way also. So for example, 106 means 100 plus 6. X is equal to the group number, which is 6. Now finding the period. Finding the period is very easy, that you have to check whether which is the principal quantum number, that is n now. So what is the last electron which is went to the which shell, K, L, M, N is there now. Second one, third one, fourth one, whichever is the last electron is falling, that is the period. Whether you have the 3s2, 1s2, 2s2, 2p6, 3s2 and 3p. And then comes the 3D, not in the 3D, they will be going to the 4s now. So which we have to consider, 3D or 4s. 4s only. The maximum number of quantum number is 4. So you have to consider the period as 4 only. Clear? So highest value of the principal quantum number is the period, that is n is the period of any element. So in order to find the block, period or a group, whatever it is, you have to do this particular electronic configuration. Electronic configuration வரைஞ்சு அதை எழுதி அதில் இருந்து தான் நமக்கு எல்லாமே கண்டுபிடிக்க முடியும். Next one is, so we are going to classification. This is like not that much important, but just like since we are discussing about all the things, we are going like with this. Metals, non-metals and metalloids. There are 3 classification where the metals, these are the metals, these are the portion which is like that green color is there, no? That is the metals, and metalloids which comes in this category, and the non-metals which is in this categories. Okay, so metals, when we are considering classification, the metals are good conductor of electricity, they are good conductors, they are highly luster, ductile and malleable, lost electrons easily. Metals always have the tendency to give electrons rather than accepting the electrons. Next one is the classification of the elements. On the non-metals are the poor conductor of poor conductors, they are brittle, they are not that much strong, they always gain electrons easily. Metalloids means they do have the properties of the metals and non-metals. We cannot say that okay they have this properties, or they cannot say that they don't have the property. So they are actually the semiconductor. Semiconductor means they can sometimes little brittle, they are very soft, and property depends upon their condition. They do have the properties which is based upon the what is the condition. Okay, now we are going to look into the penetration power or shielding effect and all. The shielding effect is actually, okay, one second. So listen carefully. This is the nucleus. Nucleus will be having the protons. I want to draw a circle. This is the first shell. Okay, this is the second shell, and we do have another shell. Consider this is the third shell. Okay, first shell, second shell and third shell. Okay, now you know the electrons will be here. Electrons will be there. Okay, so what is actually, you can understand that there will be an attraction force between the electron and the nucleus. This is the first point you can understand. There will be an attraction force between the electrons and the nucleus. Am I correct? Next, you can also get in another one. There is a repulsion between the electron and electron. Am I correct? Because see, I told you there is an attractive force. These are the attractive force. These are all the attractive forces. I don't have any issues in this. These are all the attractive forces. But what happens means there will be a repulsive force between this one and this one. between this one and this electron and this electron, between this electron and this electron, between this electron and this electron. So that repulsive force is acting as a shield for the attractive force. So when due to this attractive force, attraction force, what will be happening due to this attraction force? The particular size of the atom decreases. Size of the atom, because the nucleus positively charged, they will be attracted to the outermost electron also, and they will make them closer. So the size of the atom decreases. But due to the repulsive force, what happened to the size of the atom? The size of the atom increases. The size of the atom increases. So always that particular repulsive force which is acting as a shield, acting as a shield against this particular attractive force, that is actually called as the shielding power or shielding effect. That is actually called as the shielding effect against this particular attractive force. Whenever the electron will be, there will be a repulsion, and due to this repulsion, what happens? The size of the atom increases and they will act as a shield. They will act as a shield for the attractive force. One electron and the nucleus will be attracting. That time itself, there is an electron and electron, they will be repelling. So they are actually acting as a shield. They are actually protecting. So whenever there is a shielding effect is more, means size of the atom increases. Shielding effect. Poor shielding effect means poor shielding effect. If you got into a terms like this and all, poor shielding effect means, just a second. Poor shielding effect means there is not, the formation of the shielding is very less, which means the formation of the shielding is very less, means they cannot shield it. They cannot shield that particular electron neutron or electron nucleus between the attraction of the electron nucleus. So what happens? The attraction force increases and the size is decreasing. Size decreases. Clear? So this is, you will be coming closer with, coming in the Madri poor shielding effect and you will be coming across with in this chapter itself. So when we tell about this particular poor shielding effect also, so what happens to this particular shielding effect means s orbitals will be there. S orbitals are very closer to the nucleus and they have small in size. And they too have 2 electrons. So the electron cloud is more in the s orbital. So they will be showing more shielding effect, because between there's only having small size. The particular shell size is very small and they too have the 2 electrons. So they do have more electron density and they will be contributing more to the shielding effect. So the shielding effect order will be, shielding effect order will be S will be greater than, P is greater than, D is great. One second. Order will be S greater than, P greater than F. So S will be having more shielding effect, then P, then D, and then F. Okay, this is what they are telling, outer electronic experience and attractive force, and that is actually outer electrons experience an attractive force from the particular nucleus, and there is a repulsive force from the electrons. So there is, from this nucleus to the electrons, there is an attractive force which is in the green in color, and between the electron there is a repulsive force. So due to that, there will be a attraction also, there will be a repulsion also. So repulsive force is actually called as the shielding effect. That is actually called as the shielding effect, the effect in which the inner electrons shell in the valence shell from the attraction of the nucleus. So what happens, there will be a due to that particular repulsion or due to that particular shielding, they will be having more in size, that particular atom will be having more in size. So in a multi-electron system, the attraction between the outer electrons and the nucleus decreases, and due to the repulsion with the inner electrons. So that is how the shielding effects will be coming, and the strength of the shielding will be S is greater than, P is greater than, D is greater than F. S will be more. Okay. Now comes the effective nuclear charge, or ZEFF. So effective nuclear charge is actually the charge which is experienced on the outermost electron. So it refers to the actual charge which is experienced by the particular outermost electron. For example, you know that when the shielding decreases, what happened to the size? The size will be decreasing. So when the shielding decreases or poor shielding, the size will be decreasing, and the nucleus will be having more attraction towards the electron which is in the outermost shell. So that is the effective nuclear charge, or we can say that is Z effect. So Z effect is equal to atomic number minus the screening or the shielding constant. That is the Z effective number. Z effective is equal to atomic number minus shielding constant or screening constant. Now ZF increases from left to right across the period. So across the period, what happens in the periodic table, from left to right, the atomic size is decreasing. When the atomic size decreases, what happened to the Z effective? Z effective will be increasing. Z effective will be increasing. Atomic size decreases means the nucleus will be having more attraction over the outermost shell. I repeat, the atomic size decreases means the nucleus will be having the positive the protons which is inside the nucleus, they will be having more attraction to the outermost electron, and as a result of that, what happened? Z effective will be increasing. So when the Z effective increases from the left to right across a period, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon, they do have the have the value for the Z effective also. They will be having more. For the X block elements, lithium, sodium, magnesium, lithium, sodium, potassium, rubidium, cesium, from the top to down. Okay, top to down, what happens means they will be like from this is lithium, sodium, potassium, rubidium, from top to down, Z effective, little they will be decreases due to the increase in the size. Lithium, sodium, potassium, rubidium and all. Okay. Now trends across the periodic table. What are the trends? In this we will be discussing about exception cases, exceptions, all those things. What are the things which we are expecting? What are the things which is undergoing the exceptions and all? We will discuss about the atomic radii, ionic radii, metallic radii, van der Waals radii. In that atomic radii itself we will be discussing all those things. Then ionization enthalpy we will be discussing, electron gain enthalpy, electron affinity and electron negativity. These are the 5 important points which will be having a lot of exceptions also. We are going to discuss on this particular one. Now first we are going to discuss about the atomic radii. So atomic radii means we can simply say that it is the radius between the center of the nucleus to the outermost electrons. For example, we have a nucleus, like this is the nucleus and to the electron. This particular radius is actually called as the atomic radius, from the center of the nucleus to the from the center of the distance between the center of the nucleus and the outermost electrons of an atom is called as the atomic radius. This is a depiction. Finding the size of an atom is almost more complicated. You know that atom is such a small one, and finding the size, finding the from the distance from the nucleus to electrons is literally very difficult, because the size of an atom is very small. So we can say that there is no such sharp boundaries. Okay, this will be the correct approximate, this will be the value correct, this is the radius. It's an approximate value. There is no sharp boundary exist. Now, atomic radius size of an atom can be measured by using the internuclear distance between two identical atoms by X-ray diffraction or other spectroscopic techniques. So we can just take two atoms, and between the internuclear distance will be there. Now between the internuclear distance we can determine almost. That is actually the atomic radius they are considering. They are taking two atoms and they are considering the between this particular one internuclear distance, and that is much more easier to depict. And according to that, we have covalent radii, metallic radii, van der Waals radius. These are the three radius. It is covalent, metallic and van der Waals radii. So covalent radii, half the distance between the centers of two nucleus, in a single covalent bond. If it is a single covalent bond, so covalent bonds usually happens between the non-metals. Non-metals குள்ளதான் இருக்கும். அதுல இங்கிருந்து இது வரைக்கும் இருக்கிற அந்த distance தான் என்ன சொல்றது, அதோட and the distance the covalent radius and so d by 2, that is actually the diameter, by 2 means it's a radius, half the distance between the center of two nucleus in the same elements which is bounded by a single covalent bond, and that is the covalent radius. Generally it is occurs for the non-metals, and it's it will be angstrom, or some problems and it can be given in the picometer also, their units. Metallic radius is half the half the internuclear distance between the adjacent metallic atoms. There were non-metallic in the covalent radii, metallic atoms, and half of this is actually the metallic radius. Half the internuclear distance between the two adjacent metallic atoms in a crystalline lattice structure. Van der Waals radii means there are for noble gases also is there, for non-metals also there. Van der Waals radius are there for noble gases and for the non-metals also. For noble gases and for non-metals. For noble gases, half the distance between the nuclei of two non-bonded nearest neighboring atom of the same element in its solid state. So they will not be creating any bond. அவங்களுக்குள்ள எந்த bonds இருக்காது. They won't be creating any bonds. It's the half the distance between the nucleus. From this nucleus to this one. Okay, which is the nearest neighboring atoms of the same element. Say every element or same element or atoms are there. They won't be creating any particular bonded atoms or something. They are non-bonded atom. That is the for the noble gases. And for the now coming to the comparison of the particular metallic radius, ionic atom metallic one, covalent one, and van der Waals. So always remember இதை விட எல்லாத்தையும் விட இதுதான் ரொம்ப important. Van der Waals radius is greater than metallic radius is greater than the covalent one. You can understand from the slide itself. Slideல இருந்தே தெரியும் யாரோட இது வந்து ரெண்டு நான் பவுண்டடான எலக்ட்ரான் ஆட்டம்ஸ்குள்ள. ஸோ obviously அவங்களோட அந்த radius length வந்து நிறைய இருக்கும், இன்னும் கொஞ்சம் இன்க்ரீஸ் ஆகிடும், ரைட்? ஸோ metallic radius and covalent radius, another one more thing is metallic radius is they are not like they just அவங்களுக்குள்ள attach பண்ணிருக்காங்க, but they are not fused. But covalent radius is actually a fused one, correct? Covalent radius is actually fused one. So what happens means they will be having the covalent radius will be having the least radius. So that's why van der Waals, then metallic, then covalent radii. Because covalent radius சொல்றது sharing of the electrons எல்லாம் நடக்குது, sharing of the electrons தானே நடக்குது. ஸோ அதனால அவங்க வந்து ஃபியூஸ் பண்ணி தான் இருப்பாங்க. Than the metallic radius, than the metallic radius. So that is the reason why they will be having this order. Now factors affecting the atomic radius, of course, what are the factors which will be affecting? First of all, number of shells. When the number of the shells increases, number of shells increases atomic radii increases. When the shells increases, atomic radius will be increasing. Cesium is having more radius when compared to the lithium because cesium is having more shells when compared to the lithium. Next one is effective nuclear charge. You know that if there is more effective nuclear charge increase, effective nuclear charge another nucleus outermost electron they can attract it, right? That is actually the effective nuclear charge. So when the effective nuclear charge increases means size of the atom will be decreases, right? So they are inversely proportional. Atomic radius if the effective nuclear charge increases, atomic radius is decreasing. They are actually inversely proportional. So that's why lithium, beryllium, boron, carbon, nitrogen along the period, lithium will be having more atomic radius when compared to the other one because they have the more Z effect, more effective nuclear charge. So they will be having less atomic radius. ரொம்ப easy understand பண்ணலாம். Now comes the screening effect. Screening effect means you know that screening effect is the repulsive force between the electron and electron. As a result of this, the size of the atom is increasing. They are opposite to the particular attractive force. So screening effect increase ஆகிற சொல்லும்போது size of the atom will be increasing, which means atomic radius is more. So screening effect increases atomic radius increases. Cesium, rubidium. So இதுலயே cesium தான் more screening effect இருக்கும். They will be having like size will be too much. So that is the reason why the atomic radius is also more when compared to the lithium. Factors affecting the atomic radius. Screening effect increases, atomic size also increases. It's directly proportional. Number of bonds. So whenever number of bonds increases, what happens means, for example, nitrogen is having triple bond. There can be the single bond, double bond and triple bond. So triple bond what will be happening means they will be having more fused, they will be more attached towards it. So they will be having less atomic radius. So when the atomic radius or the number of bond increases, number of bond increases, atomic radius decreases. They are inversely proportional. That's why this will be having more atomic radius than this because this is having maximum number of bonds, so they will be having less atomic radius. Atomic radius will be less. Now, variation of the atomic radius in the group. So you know that in the group what happens in the group, what happens, principal quantum number, that is N, will be increases. For example, lithium, potassium, sodium, cesium and all, what happens means the N number, principal quantum number will be increasing. And you know that when the N increases, that is means as shells increases means the nucleus, from the nucleus to the outermost shell, the distance is increasing. So obviously the atomic radius will be increasing. So we can say in short, from top to bottom, atomic radius increases due to N increases. Principal quantum number increases, atomic radius also increases from top to bottom. Next one is variation of the atomic number in the group. For example, see here halogen and alkali metals are the lithium, sodium, potassium, rubidium, cesium and all. They are actually increasing. Here also they are slightly increasing. Next one, along the period from left to right, you know what will be happening from left to right. Z effective increases, correct? Atomic number is increasing. You may think that ma'am atomic number increase ஆகுதுல அப்புறம் எப்படி அந்த z effect increase ஆகும் கம்மி தானே ஆகுறனா பட் கம்மி தானே ஆகுற அப்படி யோசிக்கலாம் பட் என்ன ஆகுறனா atomic number is increasing ஆனா ஷெல் வந்து அங்க இன்க்ரீஸ் ஆகல அந்த பர்டிகுலர் செகண்ட் பீரியட்ல இருக்கிறது ஒரே 2 ஷெல் மட்டும் தான் போயிட்டு இருக்கு ஸோ ஷெல் இன்க்ரீஸ் ஆகாமல் இருக்கும்போது ஜெட் எஃபெக்டிவ் எலக்ட்ரான்ஸ் ஆட் பண்ணிட்டே இருக்கு அப்போ எலக்ட்ரான்ஸை வந்து அந்த நியூக்ளியஸ் அட்ராக்ட் பண்ணிட்டே இருக்கும் ஸோ வாட் ஹேப்பன்ஸ் மீன்ஸ் அட்டாமிக் நம்பர் இஸ் இன்க்ரீசிங் ஜெட் எஃபெக்டிவ் வில் பி இன்க்ரீசிங் when the z effect increases the radius will be decreasing so what happens atomic number increases z effective increases and as a result of this the nucleus and the valence electron will be having less distance because there will be more attraction so the atomic radius decreases atomic radius decreases due to the increase in the Z effective. So left to right and top to bottom. So this is what happening from the lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. They are decreasing. This is the graph. Second period. Okay. Now, so from the top to bottom, atomic radius increases down the group. Left to right, what happens left to right? It is atomic radius is decreasing. Here they have given it is in the wrong way. Atomic radius is decreasing. Children, 1 second. I have already given it. Atomic radius is decreasing. It is not increasing. It is decreases in the period from left to right. Left to right. Now irregularity. There are some some irregularities and some variation is happening. So atomic radius of inert gas that is 18th group is the largest in the period. 18th group la irukra atomic radius the group period la vechittu in largest in the period. They are the largest in the period represented by the van der Waals radius. Now van der Waals radius because they will be more respective of the whatever is the left to right top to bottom and all we discussed adellame illama atomic radius inert gases are the largest ஆகும் in the period because of this van der Waals because noble gases la நம்ம van der Waals தான சொல்லிருந்தோம் 18th groupல van der Waals radius தான் இருக்கும் generally van der Waals radius is greater because of that greater than the covalent and the metallic one. So that is the reason why atomic radius of this I will discuss in another this one here exceptions is there. So this is the reason in the particular noble gases. Now between boron, aluminum, gallium, indium, thallium, boron, aluminum, gallium, indium, thallium, which is in the boron family. So from top to bottom, boron. Now I am discussing all about the exceptions. Exceptions ரொம்ப important ஆனது boron, aluminum, gallium, indium and thallium. From top to bottom, we expected that what will we be expecting? We will be expecting atomic radius increases. Atomic radius will be increases. So the boron will be having least and thallium will be having the most. This is boron is lesser than aluminum, gallium, indium, thallium. This is what we expected. So there is an exception cases which is coming to this particular one. What is that? So you know that aluminum and gallium, okay, aluminum and gallium, they are interchanging. gallium size அலுமினியத்தை விட கம்மியா இருக்கு. So the actual order is first of all boron தான் சின்ன சைஸ் வரும். அதுக்கப்புறம் we expected aluminum. பட் அலுமினியத்துக்கு இல்ல galliumத்துக்கு தான் வரும். அதுக்கப்புறம் அலுமினியம், இண்டியம், தாலியம். இந்த டிஃபரன்ஸ் வந்து do you know why this difference அது வந்து D block. See galliumத்துல they belongs to the 3D series. So gallium என்னன்னா they will be having 3D elements. Okay, 3D10 வரும் 3D10 3D elements வரும். So இந்த 3D elements வரும்போது they will be having, I told you they will be having poor shielding effect. Poor shielding effects. It's because of the poor shielding effect of the gallium. Their size will be poor shielding effect means what is shielding effect? Due to the shielding effect the size will be increasing. But poor shielding effect means size will be decreasing. So because of the poor shielding effect, because in between these three galliumக்கு D block elements வருது. So D block elements is not supporting the shielding effect. They have the 3D, so they will be having poor shielding effect, and that is the reason why gallium is less size when compared to the aluminum. So presence of the D block elements in the gallium, and that is the reason why poor shielding effect, and it is because of the poor shielding effect gallium is having less size in the particular boron family. This is a very important point, note it down. So we expected like okay boron க்கு கம்மியா இருக்கும், அதை விட gallium அப்படி ஒரு தாலித் தான் அதிகமாக இருக்கும். ஆனால் atomic radius வந்து அதில் ஒரு exception, the first exception. This is what the exception. First exception in the atomic radius. Next one is the D block elements. Now another exception also, D block elements. I'll tell you scandium, titanium, vanadium, chromium. This is the D block elements, 3D elements: scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. So what happens means from left to right, atomic radius decreases. This is what we learned, this is what we are expecting. But so atomic radius decreases means scandiumக்கு அதிகமாக இருக்கும், titanium, vanadium இப்படி தான் போகும். ஆனால் இங்கே என்ன ஆகுறேன்னா that's true only, scandium will be having more than titanium, vanadium till chromium. Chromium is lesser than manganese. Chromium magnesium கம்பேர் பண்ணும்போது குரோமியத்துக்கு it is lesser than the manganese. manganese வந்து குரோமியத்தை விட கொஞ்சம் atomic radius அதிகமாக இருக்கு. அதுக்கப்புறம் அதை விட கம்மியாக தான் மேங்கனீஸை விட கம்மியாக அயர்ன் வருது. அயர்னுக்கும் கொபால்ட்டுக்கும் நிக்கலுக்கும் ஆல்மோஸ்ட் they have same atomic radius. It's because I'll tell you why. And again then copper is lesser than zinc. Again it is going with that. முதல்ல வந்து decrease ஆயிடும், அப்புறம் okay ஆயிடும், அப்புறம் increase ஆயிடும். So this is what happening. It's because first எல்லாம் இந்த scandium, titanium, vanadium, chromium, manganese வரைக்கும் shielding effect இருக்குல்ல, or screening effect or whatever it is, அது வந்து decrease ஆயிடும். So screening effect decrease ஆகுறேன்னா size கம்மியாய் போயிடும். So that's why scandium is more and coming to the till chromium. Okay, இங்க வந்து என்ன ஆகுறேன்னா அந்த attraction force இருக்கும், screening effect இருக்கும், அது ரெண்டுமே equal ஆயிடும். So they won't be having any size difference. screening effectum attraction forceum ரெண்டுமே சேமா இருக்கும். So they won't be having any size difference. மறுபடி இங்க ரீச் ஆகும்போது காப்பர் சிங்க் வரும்போது ஸ்கிரீனிங் எஃபெக்ட் ஜாஸ்தி ஆயிடுச்சு. ஸ்கிரீனிங் எஃபெக்ட் ஜாஸ்தி ஆகும்போது என்ன ஆயிடும், சைஸ் இன்க்ரீஸ் ஆயிடும். ஸோ தட் இஸ் த ரீசன் வை காப்பர் இஸ் ஹேவிங் more size than that is the reason why copper is having less size and zinc is having more size. So first of all screening effect கம்மி ஆயிடும், மறுபடி screening effectum atomic radiusum same ஆயிடும், அதுக்கப்புறம் screening effect more ஆயிடும். So in terms of screening I'm telling you screening effect will be less, then screening effect is equal to the attractive force. SC, okay, I have written here attraction, screening effect is equal to the attraction force, and again மறுபடி screening effect increase ஆயிடும், கம்மி ஆயிடும், equal ஆயிடும், increase ஆயிடும். So this is the order of the 3D series which is very very important and I hope it's clear also. Now exceptions on the D block elements. D block elementsல 3D 4D 5D இருக்கு. 3D 4D 5D நம்ம என்ன நினைப்போம், 3D 4D 5D. So we know that as per our knowledge from the 3D is lesser than 4D is lesser than 5D. This is what we expecting. 3D 4D because increase ஆகதா செய்வாங்க, 3D 4D 5D தானே. So top to bottom increase ஆயிடும். But what happens actually is from the 3D 4D 5D 3D is lesser than 4D which is normal, but 4D and 5D is having almost same atomic radius or atomic radius. It is because of the lanthanoid contraction. Do you know what is lanthanoid contraction? Lanthanoid contraction is the poor shielding effect. We can say that due to the F block elements have the negligence to take part in the shielding, right? So since F block elements, you know, S is greater than P is greater than D is greater than F, so F won't be taking part in this particular shielding effect. So அதனால என்ன ஆயிடும்னா அந்த சைஸ் வந்து கம்மி ஆயிடும். ஷீல்டிங் எஃபெக்ட் இல்லாம இருக்கும்போது இல்ல புவர் ஷீல்டிங் எஃபெக்ட் இருக்கும்போது size கம்மி ஆயிடும். That is why the 5D and 4D is almost having the same size. This is the reason why 5D and 4D having almost same size. But there is an exception which is scandium, yttrium and lanthanum, which is they have normal they have the normal decreasing in the size. Scandium, SCA is lesser than, Y is lesser than the lanthanum. So 4f electrons are absent in the, okay, this is not required. Next one is the ionic radius. Ionic radius are the radius between the cations and the anions. Cations and the anions means positively charged are cations and the negatively charged as the anions, right? So ionic radius is basically ions order radius, the ionic radius order. Ions are the charged species, cations and the anions. So they are actually the distance between the inner nucleus anions of a cation and an anion. அதோட அந்த ஒரு இந்த ஒரு டிஸ்டன்ஸ் தான் என்ன சொல்றது, ionic radius சொல்றது. So for the cation which is positively charged particles, அவங்களோட size வந்து கம்மியா இருக்கும். Why their size is less? Why the size is less? Because for example you have sodium 11, 1s2, 2s2, 2p6, 3s1. Na plus means they have given 1 electron. So 1s2, 2s2, 2p6. So what happens means when they given 1 electron, they have only 10 electrons in that, and the 10 electrons will be having 11 protons. They are not giving the protons anywhere, so they do give only the electrons. So 10 electrons will be there and 11 protons will be there. And the 10 electrons 11 protons which இன்னும் அதிகமாக attract பண்ண முடியும். So the size will be decreasing when compared to the parent atom. Parent atom compare பண்ணும்போது they will be having smaller than the parent atom, and because less electrons than the parent electron compare பண்ணும்போது they will be having the less electron, and that is the reason why they have the smaller size than the parent electron. They will be having more Z effective also, that is more effective nuclear charge also, because they have less size na, so they will be more attracting from the nucleus to the outermost electron. Next one is the anions. Anions are addition of electron. Electrons are added. So for example chlorine or electron add பண்றேனா, chlorine is already having, they have 7 protons and 17 protons and 17 electrons, right? So what happens here is when they are adding one more electron, they will be getting into 18 and the protons will be same. There is no change for the protons. So what happens, அதே சேம் நம்பர் ஆஃப் ப்ரோட்டான்ஸ் எலக்ட்ரான்ஸ் இருந்தானே they can attract, பட் ப்ரோட்டான்ஸோட சார்ஜ் கம்மியாக இருக்குது, எலக்ட்ரான்ஸோட சார்ஜ் அதிகமாக இருக்கும்போது அவங்கள வந்து அந்த அட்ராக்டிவ் ஃபோர்ஸ் பண்ணிட்டு இருக்க முடியாது, அவங்கள வந்து அப்படியே ஃபோர்ஸில் வந்து வச்சுக்க முடியாது. ஸோ they will be having little more size. So larger than the parental atom, they will be having more charge or more size which is larger than the parental atom, more electrons than its parent atom. See, what is the reason for that? They will be having more electrons, and since they have the more size and more electrons, they will be having less force of attraction from the nucleus to the outermost electron. Ionic radius, lithium will be having 152 and the lithium plus is having little more 76. Sodium is 186 and the sodium Na plus 95. When compared to see, chlorine is 99, but the atomic radius of Cl minus is 184. So that's why they are increasing in the terms of anion, decreasing in the terms of cations. Now comes the isoelectronic species. Isoelectronic species are the species which is having same number of electrons. ஒரே நம்பர் ஆஃப் எலக்ட்ரான்ஸ் இருக்கிற ஸ்பீஷஸை தான் ஐசோ எலக்ட்ரானிக் ஸ்பீஷஸ் சொல்கிறது. The species which is having atoms or ions which contain same number of electrons, if they are having same number of electrons, they are called as the isoelectronic species. So for example Al3+, means aluminium is 13, they have 3+ means 10, 3 electrons are given means 10. Magnesium, so this will be having 10 electrons. Magnesium is already 12, they have given 2 electrons, means this also will be having 10 electrons. Sodium is 11, they have given 1 electrons means 10 electrons. So all this will be having same number of electrons respective of their charges. So those species are isoelectronic species. So isoelectronic species are the species which will be having same number of the electrons. So ionic radius will be increasing. So when the Z effective decreases, Z effective will be decreases. See here and all, when it comes to this portion and all, they have negative charge more, which means anions more. So when the anions more means you know that Z effective will be less, because நிறைய எலக்ட்ரான்ஸ் வந்து ஆட் ஆகிட்டே இருந்தேன்னா அந்த ஒரு அவங்கள வந்து பிடிச்சி நிற்கிறதுக்கான கெப்பாசிட்டி வந்து ப்ரோட்டான்ஸுக்கு நியூக்ளியஸுக்கு இல்லாமல் இருக்கும். ஸோ Z effective will be less, அதனால radius will be increasing. So this will be having least radius and this will be having higher radius. Next one, so for the same element, this is just a reminder one. For the same element, size of the anion is less. For the same element, size of the anion is lesser than size of the atom is lesser than size of the cation. So they will be is not lesser than, greater than. Anions then normal parental atom or the normal atom, neutral atom, then cation. Cation size romba kammiya irukum, anions ku size adhigama irukum. For example, see lithium Li plus is having more size than the Mg2 plus. Next one. So now order of the radii, when we are considering the order of the radii, F minus will be having least radius and I minus will be having more radius when compared to the fluorine, chlorine, bromine, iodine. Now comes the ionization energy. Ionization energy is nothing, it is a minimal energy. We can say that kammiyan energy. It's a very minimum energy in order to remove an electron. You have the lot of electrons. These are the particular shells. So, inga irukra electrons எடுக்கிறதுக்காக இங்க எலக்ட்ரான்ஸ்னை எடுக்கிறதுக்காக எவ்வளோ எனர்ஜி நமக்கு தேவை இருக்கோ அந்த எனர்ஜி தான் என்ன சொல்றது, அயோனைசேஷன் எந்தால்பி சொல்றது. அயோனைசேஷன் எந்தால்பி இஸ் த மினிமம் எனர்ஜி. இட் இஸ் த மினிமம் எனர்ஜி required to remove the most loosely bounded electron from an isolated gaseous atom. There should be only single isolated gaseous atom in their ground state. It's not in the excited state or something, it's in their ground state. For example, M இருந்தது gaseous stateல இருந்து ஒரு எலக்ட்ரான் எடுக்கிறதுக்காக எவ்வளவு எனர்ஜி வேணுமோ அதான் minimum energy, that is the ionization enthalpy. So ionization enthalpy means which is the ionization enthalpy or ionization energy is the energy required to remove, it's a minimum energy required to remove the most loosely bounded electron from the isolated gaseous atom. So this unit is kJ bar mole, kilocalorie bar mole. EV also. EV is the normal unit which is given in the question paper and all usually. kJ bar mole also is given. Now, quantitative measurement of this tendency of an element is to lose an electron. We can say that ஒரு electron lose பண்றதுக்கு எவ்வளவு எனர்ஜி நம்ம கொடுக்கணுமோ அந்த எனர்ஜி தான் என்ன சொல்றது, ionization energy சொல்றது. And smaller the size of, smaller is the ionization energy, easier it is for a neutral atom to change itself into a positive ions. What do you mean by that? What do you mean by that? When அந்த எலக்ட்ரானோட சார்ஜ் அந்த எலக்ட்ரானை எடுக்கிறதுக்காக அயோனைசேஷன் எனர்ஜி கம்மியாக கொடுத்தா போதும். ஓகே, ஸோ வி ஆர் கிவிங் மினிமம் எனர்ஜி. ஃபார் எக்ஸாம்பிள் 1000 EV ஆர் சம்திங். நம்ம 1000 EV இல்லை, அவ்வளோ இங்கிலீஷ் வேணும், 500 EV ஆர் 400 EV ஆர் சம்திங் வி ஆர் கிவிங் தட். ஓகே, நம்ம அது கொடுத்துட்டோம். அது கொடுக்குற டைம், அது கொடுத்துட்டு அது கொஞ்சம் தான் கொடுத்துருக்கோம், லெஸ் எனர்ஜி தான் கொடுத்துருக்கோம். அது கொடுக்குற டைமில் this electrons will be removing. இந்த electron வந்து இந்த shell இருந்து remove ஆயிடும். Correct? This electrons will be removing. அந்த energy கொடுக்கிற timeல இந்த electron remove ஆகும். அப்போ easy to form that particular cation. When the electron removes, it will be forming the positive ions, cations. So that's why if you are giving the lesser energy, if you don't want to give that much energy, நம்ம எடுத்தது அப்படியே போக்கு கிடைச்சிருச்சு. We are just taking it away just like ஈஸியாக எடுத்துட்டேன்னா ஈஸியாக அந்த பர்டிகுலர் ஆட்டம் வந்து கேட்டியோன் ஃபார்ம் ஆகிறதுக்கு ரெடியாக இருக்கு. They are ready to lose electron. If that particular atom is ready to lose electron, நம்ம சின்ன எனர்ஜி கொடுக்கும்போது சரி போய்க்கோ சொல்லிட்டு அவங்க எடுத்துருவாங்க. Okay, so that is the reason why they are telling like it is easier to form this particular positive ions. Ionization energy on the atom is always positive. It is always positive. Now, first ionization energy. You have second ionization energy, third varum, fourth varum. First ionization energy is ஒரு நியூட்ரல் ஆட்டத்தில் இருந்து எலக்ட்ரான்ஸை கொடுக்க வாங்க ஒன்றும் செய்யலை. ஒரு நியூட்ரல் ஆட்டத்தில் இருந்து ஒரு எலக்ட்ரான் எடுக்கிறதுக்காக எவ்வளோ எனர்ஜி நம்ம கொடுக்குறதோ அதுதான் ஃபர்ஸ்ட் அயனைசேஷன் எனர்ஜி சொல்கிறது. த எனர்ஜி ரிக்வயர்ட் டு ரிமூவ் த அவுட்டர்மோஸ்ட் எலக்ட்ரான் from a gaseous neutral atom. M இருக்கிறதுல இருந்து நியூட்ரல், there is no specific charge, அதில் இருந்து ஒரு எலக்ட்ரான் ரிமூவ் ஆகிறதுக்காக how much energy we are giving, that is the first ionization energy of that particular one. That is the first ionization energy. Second ionization energy na second electrons எடுக்கிறதுக்கு. ரெண்டாவது எலக்ட்ரான்ஸ் எடுக்கிறதுக்கு எவ்வளோ எனர்ஜி கொடுக்கணும், தேர்ட் எலக்ட்ரான்ஸ் எடுக்கிறதுக்கு எவ்வளோ எனர்ஜி கொடுக்கணும். ஸோ ஆல்ரெடி செகண்ட் டிரான்சிஷன் எனர்ஜி சொல்லும்போது செகண்ட் எலக்ட்ரான்ஸ்னா ஆல்ரெடி ஒரு எலக்ட்ரான் போயிருக்குன்னா தேர் ஆல்ரெடி இந்த ஸ்டேட் ஆஃப் 1+1 or 1+. ஆல்ரெடி ஒரு எலக்ட்ரான் போயிட்டு தான் ஃபர்ஸ்ட் ஆன்சர்ஷன் எனர்ஜி வந்திருக்கும், 1 எலக்ட்ரான் போயிருக்கும். நெக்ஸ்ட் செகண்ட் ஆன்சர்ஷன் எனர்ஜினா இந்த போனதுல இருந்து ஃபர்ஸ்ட் ஆன்சர்ஷன் எனர்ஜில தான் செகண்ட் ஆன்சர்ஷன் எனர்ஜிக்கு வர. ஸோ இட் வில் பி ஆக்சுவலி 2+ 1 electrons will be giving. I repeat, my dear students, first of all they were in the state of like, okay, nothing is there, no charge, nothing is there, just like M. Okay, now someone came and I'm giving 1 electron. So I was already having 10 electron. அதுலேருந்து வந்து கொடுத்துட்டா 9 எலக்ட்ரான் ஆகிட்டு. ஸோ ஐ வாஸ் ஆக்சுவலி லூசிங் எலக்ட்ரான். ஸோ நான் வந்து +1 தான் இருந்தேன். மறுபடியும் ஒருத்தர் வந்து ஒரு எலக்ட்ரான் கேட்குறாங்க. ஸோ நான் M+ல் இருக்கிற நான் தான் மறுபடியும் கொடுக்குறேன். ஸோ தட்ஸ் வை தே ஆர் கிவிங் M+ and they are giving that 1 electron and that how they அந்த M+ல இருந்து ஒரு எலக்ட்ரான் கொடுக்கும்போது அது என்ன ஆகிடும், M2+ ஆகிடும். and that is the IE2. and you have I3 means என்னதான் இருக்கும், இந்த M2+ ஆல்ரெடி 2 எலக்ட்ரான்ஸ் கொடுத்துருக்கு, IE1 IE2. அதுல இருந்து இன்னொரு எலக்ட்ரான் கொடுக்கறதா IE3 வருது. that is the energy required to remove the third most loosely bounded electron, and this is the IE3 from M2+. They will be asking you the question like M2+, which will be the I3 or I2. Or if it is M2+ means okay, 2 electrons already போயிருக்கு, அதுல இருந்தா மறுபடியும் கொடுக்குறேன். So 2 electrons already போயிருக்குன்னா IE1 கொடுத்துருக்காங்க, IE2 கொடுத்துருக்காங்க. So it will be IE3. Now the question is, which one will be having the largest, which one will be having more energy, more value for the ionization energy? Always remember, see, நான் இப்போ 10 இருந்தது, ஒரு ஆள் வந்துட்டான் என்கிட்ட கேட்டாங்க ஒரு எலக்ட்ரான், I gave them 1 electron. So then I changed to 9. Okay, so I was 10 electron and 10 proton at the initial time. Now I became 9 electron and 10 proton again, which means electrons கம்மி ஆகுது, protonsக்கு எந்த சேஞ்சும் வரல. ஸோ ஒரு எலக்ட்ரான் கொடுத்ததும் protons என்ன பண்ணுவாங்கன்னா அட்ராக்ட் பண்ணி வச்சுருவாங்க. they will be attracting me. எப்படின்னா see, இதுல இருந்து ஒரு எலக்ட்ரான் போயிடுச்சு. ஸோ இந்த ஷெல்லே அங்கே இல்லை, இந்த ஷெல்லே the entire shell is went. ஸோ இந்த இதுக்குள்ள ப்ராட்டான்ஸ் வந்து இந்த பர்டிகுலர் எலக்ட்ரான்ஸ் எல்லாத்தையும் அட்ராக்ட் பண்ணி வச்சுடுவாங்க. ஆமா தானே, correct? So when they are actually like they are just size is decreasing, then again ஒரு IE2 வேணும், இன்னொரு எலக்ட்ரான் தாங்க சொல்லிட்டு வரும்போது மறுபடியும் அவங்க கொடுக்கும்போது மறுபடியும் 8 எலக்ட்ரான்ஸ் தான் இருக்கும். அந்த 8 எலக்ட்ரான்ஸ் சேர்த்து 10 ப்ரோட்டான்ஸ் இருக்கு. சார்ஜ் ஆஃப் த ப்ரோட்டான் இஸ் மோர், so they will be tightly they will be attraction. So இன்னும் வர வந்து லைக் they need another electron வந்துட்டு யாராவது வரேன்னா அவங்க வந்து நிறைய எனர்ஜி கொடுக்கணும். ஃபர்ஸ்ட் எலக்ட்ரான் எடுக்கிறதுக்கு ரொம்ப எனர்ஜி தேவையில்லை, பிகாஸ் 10 ப்ரோட்டான் அண்ட் 10 எலக்ட்ரான். ஆனால் நெக்ஸ்ட் ஸ்டேட் அது கேட்டியோன் ஆயிடுச்சு. கேட்டியோன் ஆகுறேன்னா அவங்க வந்து அவங்களை அட்ராக்ட் பண்ணி வச்சிருப்பாங்க. ஸோ நான் கொடுக்க மாட்டேன்னு சொல்லிட்டு இவங்களை புஷ் பண்ணுவாங்க. வரவங்க வந்து அப்போ அந்த புஷ்ஷை தாண்டி நிறைய எனர்ஜி கொடுத்துட்டு வேணும் அந்த எலக்ட்ரான் எடுக்கிறதுக்கு. ஸோ IE2 இஸ் ஆல்வேஸ் கிரேட்டர் தென் IE1. IE2 second ionization energy is greater than first ionization energy. ஆனால் IE3 சொல்லும்போது கேட்டியோன் அவ்வளோ ஃபார்ம் ஆயிருக்கு, +3+2 ஸ்டேட்ல இருக்கு. they will be having very less size, so they have the most attraction of the nucleus. அந்த அட்ராக்ஷனை சப்ரஸ் பண்ணி எனர்ஜி கொடுத்துட்டு வேணும் அந்த எலக்ட்ரான் எடுக்கிறதுக்கு. so the IE3 will be that much energy they have to give. IE3 is more, usually IE3 will be more when compared to the all other things. Removal of an electron from a cation is more difficult. Removal of an electron from the cation is more difficult than the neutral gaseous atom. Therefore always remember IE3 will be more energy because they have to suppress the cations. அவங்களோட அந்த அட்ராக்ஷன் ஃபோர்ஸை சப்ரஸ் பண்ணி அவ்வளோ எனர்ஜி கொடுத்து அங்கிருந்து அப்படியே எடுத்துகிட்டு வர்றதுக்கு கஷ்டம். ஆல்ரெடி நம்மக்கிட்ட 3 சாக்லேட்ஸ் இருந்தது, சரி ஒன்று கொடுப்பியா, சார் ஓகே 1 எடுத்துக்கோ, ஒன்றும் பிரச்சனை, 2 இருக்குல்ல. இன்னொருத்தர் வந்து இன்னொன்று கேட்குறாங்க, இல்லை நான் கொடுக்க மாட்டேன், என்கிட்ட 2 மட்டும்தான் இருக்குது. அப்போ அவங்க அவ்வளோ நம்மளை கன்வின்ஸ் பண்ணி வேணும் இன்னொன்று எடுக்கிறதுக்கு, கரெக்ட்? மறுபடியும் இன்னொன்று இருக்குது. ஸோ அவங்க கன்வின்ஸ் பண்ணி அவங்க மேபி சண்டை போட்டு எடுக்கணும். ஸோ they have to spend that much energy. So that is the same theory we are applying here also. So successive ionization energy when compared lithium. See, listen carefully children, this is very important. Li 1s2 2s1, okay, 1s2 2s1. So this s is actually first ionization energy எடுக்கும்போது இந்த ஒரு s வந்து போயிருப்பாங்க. This s ல இருந்து இந்த 1 electron போயிருப்பாங்க. They will be in the state of 1s2 when this 520 ல 520 கொடுத்துட்டு அவங்க ஒரு எலக்ட்ரான் எடுத்துட்டாங்க. மறுபடியும் இந்த ஒரு particular one வரும்போது they have again increasing the energy. Correct? Because என்ன ஆகுறேன்னா இருக்கிறதே ரெண்டு தான், அந்த ரெண்டுல மறுபடியும் கேட்குறேன்னா இட்ஸ் really difficult, right? So that's why they are increasing, and at least next one they will be increasing much more. Clear? That's all happening in this particular one. IE3 is more than IE2 is greater than IE1. Lithium, beryllium. There are some exceptions which we are going to discuss now. Okay. Now, factors affecting the ionization energy. Always remember when the size of the atom more size இருக்கிறேன்னா எனக்கு வந்து ஒரு 10 ஸ்டூடெண்ட் என்னோட கிளாஸ்ல இருக்கு. ஓகே, அப்போ கிளாஸோட இன்க்ரீஸ் இட் இஸ் வெரி பிக் கிளாஸ். ஐ மீன் 10 ஸ்டூடெண்ட் இருக்குது, இன்னொரு கிளாஸில் 15 ஸ்டூடெண்ட் இருக்குது. ஸோ 15 ஸ்டூடெண்ட்ஸ் இஸ் வெரி மச் டிஃபிகல்ட் டு மெயின்டைன் ஆல் திஸ் 15 ஸ்டூடெண்ட்ஸ். நீ என்ன பண்ணுற பார்க்குறதுக்கு எனக்கு ரொம்ப கஷ்டமாக இருக்கும். அதில் ஒரு ஸ்டூடெண்ட் வந்து ஏதோ பண்ணாமல் இருந்தால் கூட எனக்கு அது தெரியணும்னு இல்லை. அதே மாதிரி தான் இங்கேயும் சைஸ் இன்க்ரீஸ் ஆகும்போது அயோனைசேஷன் எனர்ஜி அவங்களுக்கு டிஸ்ட்ராக்ஷன் ஈஸியாக இருக்கும். ஸோ தே ஹாவ் டு கிவ் லெஸ் எனர்ஜி ஆன்லி. அயனைசேஷன் எனர்ஜி டிக்ரீஸ் ஆகிடும். இல்லைன்னா சைஸ் இன்க்ரீஸ் ஆகும்போது நியூக்ளியஸுக்கு வந்து எலக்ட்ரான்ஸை வந்து அட்ராக்ட் பண்ணிட்டு இருக்கிற வரைக்கும் அட்ராக்ட் பண்ணுற அந்த ஒரு கெப்பாசிட்டி கம்மி ஆகிடும். சைஸ் இன்க்ரீஸ் ஆகும்போது சைஸ் இன்க்ரீஸ் ஆகும்போது நியூக்ளியஸுக்கு வந்து அந்த எலக்ட்ரானை அட்ராக்ட் பண்ணுற அந்த கெப்பாசிட்டி டிக்ரீஸ் ஆகிடும். ஸோ ஈஸியாக நமக்கு வந்து அந்த எலக்ட்ரானை எடுத்துக்கலாம். ஸோ வி டோன்ட் வாண்ட் டு கிவ் தட் மச் எனர்ஜி டு தட். அண்ட் size increases, size of the atom increases means we have to ionization energy will be decreasing. Effective nuclear charge, which is Z effective, அது increase ஆகுறேனா effective nuclear charge means we are increasing the nuclear charge, so the size will be decreases. Size decreases means nucleusல அந்த electrons outermost electrons கூட நல்ல attraction force இருக்கும். so யார் வந்தாலும் அவங்க வந்து நிறைய effort போட்டு தான் அந்த electrons எடுக்க முடியும். so obviously the ionization energy has to give more. Screening effect means screening as a result of the screening effect. Size increases at one second. Size increases means ionization energy decreases. They don't want to give that much effort. Penetration effect increases means ionization energy increases. Penetration means they are penetrating, that particular shells are penetrating into the nucleus. So S, P, D, F, S க்கு நல்ல penetration இருக்கும் towards the nucleus, then P, then D, the F. So what happens to the size? Size is decreasing, ionization energy is increasing. Electronic configuration. Now between the electronic configuration, fully filled is greater than, half filled is greater than the partially filled. For example, this is a fully filled. This is your half filled. So this is fully filled, this is partial, half filled, this is partial filled. okay, fully filled இருக்கும்போது for example s orbital, p orbital and d orbital, this is spd. okay, இந்த s orbital already அந்த ஆர்பிட்டலுக்கு தேவை 2 electrons தான், அந்த electrons கிடைச்சிருக்கு, அந்த electrons அவங்க கொடுக்கிறதுக்கு ரெடியா இருக்குமா நியூக்ளியஸ் இல்ல. ஸோ வரவ யாரா இருந்தாலும் நிறைய எனர்ஜி போடுதா இருக்கணும், எனக்கு கிடைக்கணும்னு சொல்லிட்டு எலக்ட்ரான்ஸை எனர்ஜி எடுத்தாதான் ஆகணும். எஸ்பெஷலி s orbital எல்லாம் இப்போ 1s எல்லாம் இருக்கிறேன்னா அந்த நியூக்ளியஸ் கிட்ட பக்கத்துல இருக்கிறவங்க 1s எல்லாம் 1s 2s எல்லாம், ஸோ அவ்வளோ எனர்ஜி கொடுத்தாதான் கிடைக்கும். okay, same thing for the pd and d also, p and d also, they have already filled. நான் p6 இருக்கேன், நான் நிம்மதியா இருக்கேன், இன்னொருத்தர வந்துட்டு ஒரு எலக்ட்ரான் எடுத்து போயிட்டேன்னா என்னோட ஸ்டெபிலிட்டியே போயிடும். ஸோ வரவ யாரா இருந்தாலும் என்ன பண்ணணும், they have to give more energy. same thing happened to the half filled also in the spd. in the spd also the same thing happened, half filled இருந்தாலும் நான் half filled இருக்கேன், எனக்கு அட்லீஸ்ட் lit அந்த partial filled காட்டிலும் ஸ்டெபிலிட்டி இருக்கு. so so whoever it is coming they have to give more energy. so usually ionization energy in the period across the period, okay, from left to right. left to right across a period from left to right, you know that effective nucleus will be increases, there will be size decreases, so ionization energy will be increases. in the group the size will be increases, ionization energy is decreases, they don't want to give that much energy. but there are some what to say, the order of the first and second ionization energy, we expected that lithium beryllium boron, there is some exceptions for this, these are exception ones, this is exception, this is also exception. okay, idhil exceptions. second okay, so lithium beryllium, so நம்ம என்ன நினைப்போம்னா left to right தானே, so lithium beryllium boron carbon nitrogen oxygen fluorine neonல left to right size increase ஆயிடும், so ionization energy size decrease ஆயிடும், ionization energy increase ஆகும். so we expected lithium is less then beryllium boron carbon nitrogen oxygen. ஆனா இந்த ரெண்டு இடத்துலயும் there is an exception, because beryllium and boron, beryllium is lithium, hydrogen, helium, lithium, beryllium, 4 1s2 2s2 is the electronic configuration of beryllium, hydrogen, helium, lithium, beryllium, and nitrogen 7 1s2 2s2 2p3. okay, here this is fully filled, here this is half filled, so fully filled and half filled they will be having, they have to give more electron ionization energy. so between beryllium and boron, beryllium will be having more energy, they have to give more energy to the electron. so அதனால beryllium boronக்கு முன்னாடியே beryllium வந்துடும். and we expected carbon nitrogen oxygen, but oxygen விட nitrogenக்கு தான் நிறைய electron, they have to give more energy, so because they have already half filled, so that's why oxygen then nitrogen, oxygen will be having less ionization enthalpy than compared to the nitrogen. same thing in the second ionization enthalpy வரும்போது it will be completely different, because beryllium will be having least. why means ஒன்னு கொடுத்துட்டா 2s2 ல இருந்த beryllium 2s1 ல ஆயிடுச்சு, which means அவங்க ஒன்று கொடுத்துட்டேன்னா இன்னும் ஈஸியாக இருக்கும், இது எடுத்துக்கோங்கப்பா, இது எடுத்துட்டேன்னா எனக்கு 2s போயிடும், 1s2 ல இருந்திருக்கலாம், 1s2 ல இருந்தது நான் இன்னும் s2 தானே sல தானே 2 தானே, அப்போ இன்னும் ஸ்டேபிளாக இருக்கும். ஸோ நீ வேற உனக்கு வேணுமா எடுத்துக்கோ சொல்லிட்டு எலக்ட்ரான்ஸ் கொடுப்பா, அதனால லீஸ்ட் beryllium, then carbon, then boron, nitrogen, fluorine, oxygen, neon and lithium. Lithium means why second for the lithium means 1s2 hydrogen, helium, lithium 1s2 2s1 தான் இருக்கும். first and electronic configuration is 1s2 2s1. first electron கொடுக்கிறதுக்கு எந்த பிரச்சனையும் இல்லை, எடுத்துக்கோ எனக்கு ஸ்டெபிலிட்டி கிடைச்சிருச்சு 1s2 ல தானே இருக்கு. ஆனா செகண்ட் ionization enthalpy எடுக்கும்போது this is actually 1s2, நியூக்ளியஸோட கிட்ட s orbital fill ஆயிருக்கு, so we have to give more energy for taking from this particular 1s2 ல இருந்து ஒரு எலக்ட்ரான் எடுக்கிறதுக்கு இன்னும் எனர்ஜி கொடுக்குறோம், அதனால லிதியத்துக்கு வந்து இன்க்ரீஸ் ஆயிடும், நியோனை விட இன்க்ரீஸ் ஆயிடும். Now, order of the first ionization energy in the 13th group. This is also important. Here I have written it. So, which are the exception cases and all. One second. Idhula வந்து it is due to the pure. One second, where it is. First of all, we can discuss this and then we can go more to the back. So, fluorine and neon expected one. Fluorine and neon in consider pannabodu. This has asked as a question in one of the exam. I don't remember which exam. They have asked as a question this. Fluorine, neon, we will be expecting that fluorine is actually greater than the neon. Carbon, nitrogen, oxygen, fluorine, neon. Fluorine is, but what happens means neon is actually more ionization energy, which is, see, this is what we expected, but this is actually the exception cases for the neon. Neon will be having more because of the stable electronic configuration. Because of the stable electronic configuration, neon will be having, they have to give more energy to the neon. Okay, next one is this one. Yes, 3D, 4D, 5D. 3D, 4D, 5D, the atomic radius, this is the order of the atomic radius due to this poor shielding effect and all those things. Like 5f orbital won't be lanthanide contraction, they will be having poor shielding effect. So 3D, 4D is approximately equal to the 5D. So we expected this particular ionization energy also the same way. Ionization energy, this is the ionization energy which we are expecting. 3D is greater than, because they have lesser size, so you have to give more energy, but 3D is greater than 4D is approximately equal to 5D. But what happens here is 5D is having, this is a very important one, which is very important one. You can star it because they have asked in many time. They have asked romba nariya vaati vandu exam la ketirukanga. 3D is greater than 4D is, this one 5D, this is what we are expecting for the ionization enthalpy, but this is what the exception comes. 5D ki da nare ionization energy venum. Edha vida 3D and 4D vida. Because due to the lanthanoid contraction, what happens means removal of this electron is difficult. Lanthanoid contraction 5D la வந்து lanthanoid contraction வரதுனால size ரொம்ப கம்மி ஆயிடும். அந்த எலக்ட்ரானை எடுக்கிறதுக்கு நிறைய எனர்ஜி கொடுக்க வேண்டியதா இருக்கும். I repeat, due to the lanthanoid contraction, size ரொம்ப கம்மியா இருக்கிறதுனால அந்த எலக்ட்ரான்ஸ் எடுக்கிறதுக்கு we have to give more energy. So, remember this one. This is very important. 5D is greater than 3D is greater than 4D. 5D is greater than 3D is greater than 4D in the series. 3D, 4D, 5D series. This is the order of the ionization enthalpy. We will do the questions. That time you will be getting more idea. Same thing is happening here. Boron, aluminium, gallium, boron, aluminium, gallium, indium, thallium. From top to bottom, size increases, ionization enthalpy decreases. So we expected boron will be having the more, and the indium will be having the less. But what happens means thallium வந்து 5D series la varudhu. So they will be coming first one. Then gallium, then aluminium, then indium. Thalliumthukku due to the lanthanoid contraction, what happens? They will be having less size. So we have to give more energy. Not more than boron, what we have to give to boron, but we have to give more energy. Then gallium varum. And again galliumthukku vandu 3 orbitals varudhu, 3D varudhu. So they, of course, they will be having much more poor shielding than the indium. Clear? So this will be indium is lesser than aluminium is lesser than gallium, thallium and boron. This is also very important one. Very important one. And this one also. In the series, 5D, 3D series and the period, across the period. Now points to remember, ionization enthalpy of the non-metal. Of the non-metals will be always greater than the metals. Noble gases have the highest ionization enthalpy because they do not want to give the electrons. Cesium has the lowest ionization enthalpy because of their size. So it is used in the photoelectric cells and all. They can emit electrons very fastly. Helium has the highest ionization energy. There we have to give more energy to take the helium, because helium is having very less size now. They belongs to noble gas and they do have this less size also. Now, metallic character. Metallic character means how easily an element loses the electrons in the chemical reaction. எவ்வளோ சீக்கிரமாக ஒரு எலக்ட்ரான்ஸ் வந்து ரிமூவ் ஆக முடியும், அதுதான் என்ன சொல்கிறது, ஒரு எலமெண்ட்டோட இல்லைன்னா ஒரு மெட்டாலிக் கேரக்டர் சொல்கிறது. எலக்ட்ரான்ஸை ரிமூவ் பண்ணுற கேரக்டர். ஸோ மெட்டாலிக் கேரக்டர் இன்க்ரீசஸ் மீன்ஸ் அவங்களோட அயனைசேஷன் எனர்ஜி எந்த இருக்கும், டிக்ரீஸ் ஆகிடும். அண்ட் தே ஆர் ஆல்ரெடி ரெடி டு கிவ் த எலக்ட்ரான்ஸ். ஸோ மெட்டாலிக் கேரக்டர் இன்க்ரீசஸ் மீன்ஸ் எலக்ட்ரான்ஸ் கிவ் பண்ணுற டெண்டன்சி இன்க்ரீஸ் ஆயிருக்கு, விச் மீன்ஸ் தேர் அயனைசேஷன் எனர்ஜி இஸ் டிக்ரீசிங். நான் மெட்டாலிக் கேரக்டர் மீன்ஸ் they are ready to accept the electrons, not giving. So non-metallic character increases means we have to give more energy. They are not ready to give the electrons, they are already ready to take the electrons. So we have to give more energy. Next one is electron gain enthalpy. So this is actually a little different from the ionization enthalpy, like opposite of the ionization enthalpy. Not exactly the opposite, but we can refer it like that. Okay. Enthalpy change, the enthalpy change when an electron is added to the neutral gaseous atom to convert into an anion. Ionization enthalpy சொல்றது நம்ம வந்து cation தான் ஆக்கிட்டோம் அந்த எலக்ட்ரான் எடுத்துட்டு. இந்த எலக்ட்ரான் கெயின் என்தால்பி சொல்றது ஒரு நியூட்ரல் ஆட்டத்துக்கு நம்ம ஒரு என்தால்பி எவ்வளவு சேஞ்ச் வருது, ஒரு ஆட்டம் ஒரு எலக்ட்ரான் வந்து ஆட் பண்ணி அந்த பர்டிகுலர் கேஷியஸ் ஆட்டத்தை வந்து நம்ம நெகட்டிவ் சார்ஜ்டு அயோன் ஆக்கும்போது how much energy is changed or what is the enthalpy change, that is the electron gain enthalpy. See, x, they are adding electrons and they are giving x minus. Ionization enthalpyல அவங்க எடுத்துட்டாங்க, அதுக்கப்புறம் x plus ஆகுது, x minus ஆயிடுச்சு. This is the unit of the electron gain enthalpy. Now, electron gain enthalpies are two types, positive and negative. Positive electron gain enthalpy is also there, negative electron gain enthalpy is also there. Positive electron gain enthalpy means when the energy is absorbed. எப்போ எனர்ஜி அப்சார்ப் ஆகும்னா when the particular atom is not ready to accept the electron. எனக்கு வந்து எலக்ட்ரான் தேவையில்லை, நான் ஆல்ரெடி ஃபில்டாக இருக்கேன், நான் ஆல்ரெடி ஹாஃப் ஃபில்டாக இருக்கேன், நீ ஒரு எலக்ட்ரான் எனக்கு கொடுத்துட்டேன்னா என்னோட அந்த ஸ்டெபிலிட்டி போயிடும். அந்த ஒரு சிச்சுவேஷனில் வந்து that particular element is not ready to accept an electron, and that is where we are saying that they have the positive electron gain enthalpy and where the energy is absorbed. Now, negative means they are adding into that. So, energy is released. எப்போ 2p2 இருக்கிற டைம்லலாம் 2p2 இருக்கு, ஓகே எனக்கு ஒரு எனர்ஜி எலக்ட்ரான் நீ யாராவது கொடுத்துக்கோங்க, நான் 2p3 ஆகிடும், நான் ஸ்டேபிள் ஆகிடும். ஸோ தே ஆர் ரெடி டு அக்செப்ட் த எலக்ட்ரான். They are ready to accept. So, negative value for the delta EGH means they are ready to accept the electron. So, they will be releasing the energy and they will be giving the electrons, or they will be accepting the electrons. And positive means they are not ready to accept get the electron. I don't want the electron, I'm already stable. Many conditions, due to the small size or due to the stability, they are not ready to accept the electron, won't accept the electron. See, won't accept the electron. Here, ready to accept the electron. These are the differentiate between the positive and negative. Positive means in the electron gain enthalpy, positive means they don't want the electron, so they will be showing positive charge for the electron gain enthalpy. Okay, now magnitude of how this electron gain enthalpy. So when atomic size increases, electron gain enthalpy decreases. Why electron gain enthalpy decreases? Atomic size increases means it's easy to give the electrons because there is no, say atomic size increases means attraction, see they will not be having that much they have more size, correct? So when the atomic size increases means they have to give less energy only to add that electron, because there will be enough space. So easy add பண்ணலாம், எந்த repulsion எந்த attraction பிரச்சனை இல்லை. Z effective decreases means atomic size increase ஆயிடும். So they will be like, we have to give, when the Z effective decreases means atomic size will be increases, they have to give less energy only, less value for electron gain enthalpy. Screening effect increases means again atomic radius will be increasing, electron gain enthalpy will be decreasing. They don't want to give that much effort to give that electron, because there is no that much repulsive force also, because they have electron cloud is very far. So the incoming electrons, incoming electrons, they won't be facing any repulsion because they have enough and more size, enough and more space. Half filled or fully filled subshell, here the ionization enthalpy is decreases because they will be like, they don't want it. Okay, so it will be positive actually. So electron gain enthalpy across a period, what happens across the period from left to right? Size decreases, this particular Z effective increases and size decreases. What happens when size increases? They have to give more electron gain enthalpy. Opposite. Now comes the second period. So second period we expected this particular one. But what happens? There is an exception here. Neon, beryllium and nitrogen. So they don't want that much one. I don't want it because I'm already stable. Neon is already stable. I have already filled electrons. Electron I don't want it. So what happens? They are fully filled. Even this neon and beryllium is fully filled. So they are not ready to accept an electron. So they won't showing that much electron affinity. They will be having less electron affinity. Even nitrogen also. All other electrons will be required. Requires the electrons. Are you getting my point? So this is the trend. So this will be having least value for the electron gain enthalpy. This will be having least value for the electron gain enthalpy. Next one is down the group. From top to bottom. Down the group. Size increases. Size increases means what will be happening to the magnitude? They don't want that much effort. They don't want to put that much effort. They can easily add on to the electrons to that. So delta EGH will be less magnitude. Now always remember this is another very important one. Electron affinity or electron gain enthalpy of (3p) is greater than 2p. 3p elements they will be having more electron affinity when compared to the 2p. Why means in the 2p elements now, if fluorine, chlorine வரும்போது chlorine more electron affinity இருக்கும் இல்ல electron gain enthalpy இருக்கும் fluorine விட. ஏனா fluorine வந்து already they have the smaller size when compared to 3p and 2p. You know that 2p will be having less size. They do have more electron density also. சின்ன சைஸா இருக்கு அதிலே electron density இருக்கு ஆமா தானே இன்னொரு electron வேறனா they will be this all electron density around this fluorine and they will be repelling that particular electron, right? So there will be more repulsion in the upcoming electrons. So electron affinity will be lower. Electron affinity will be lower. So magnitude of the EGH of 3D elements are greater than the corresponding 2 period P block elements. Because see CLF is more than F, Cl is more than F, sulfur, this is 3p, this is 2p, this is 3p, this is 2p. This is the reason why this is the reason for the 2p and 3p. So it happens because 2p second period element, that is fluorine and oxygen have the smallest size. So the addition to that particular, in order to add that particular electron respective the group and the addition of the extra electron will be causing a greater repulsion in the second period element. So chlorine will be having more electron affinity when compared to the fluorine. This is a sure question. They will ask you. They will ask you as in the written formula which one is wrong, which one is right. அப்படி கேட்பாங்க. Now why such exceptions? ஏன் such எதனால அந்த exceptions வருதுன்னா it is easier to add an electron to chlorine. It is easier It is easier to add an electron to the chlorine and the sulfur due to its large size. அது accumulate பண்றதுக்கு ஈஸியா இருக்கும். and large size-ஆ இருக்கு அவங்களுக்கு ஒரு electrons add பண்றதுக்கு எந்த பிரச்சனையும் இல்லை because they are enough size for that to accumulate an electron. When compared an extra electron more easily compared to the second period. This is not the third one, children. Second period elements. Okay, so chlorine has the highest electronegativity value, delta EGH value. EGH value of the noble gases is positive because it's already have the stable configuration. They do have the stable configuration and they don't require another electron. So they will be having the positive. They are not ready to accept an electron. They will be having positive values and it becomes comparatively unstable. If they have addition of an electron they will be unstable. So they are actually having positive value for the noble gases. Delta EGH for the addition of the second electron to a neutral atom is positive. So this is the delta H for the addition of the second electron. They won't be like or atomக்கு வந்து they won't be encouraging that particular attraction because electron repulsion outweighs the nuclear attraction. So listen carefully, always listen carefully. See O plus O இருந்தது ஒரு electron கிடைச்சிருச்சு, they become O minus. Okay, and they were having negative value. But already O negative இருக்கு. already they have the repulsion force greater than the attraction force. They are repelling actually. Anions now, they actually have the repulsion and they are actually having the more size. So when they are again adding an electron means they won't support it. So they will be having the positive value. They don't want it because already the repulsion is having repulsion is greater. The repulsion is having the greater value when compared to the attraction. So what happens means they will be having the positive value. First electron gain enthalpy, okay fine, they will be having negative, but the noble gas it will be having positive. But oxygen, in the case of oxygen, it will be having negative. Then they become to the anion state, they are negative. Again one electron is added means what happens, they become O2 minus. So they don't want it because they are already having repulsion force, they cannot accept it. So they will be having positive, showing positive value. Second and the subsequent electron gain enthalpies are always positive. செகண்ட்ல இருந்து தேர்டா இருக்கட்டும், ஃபோர்த்தா இருக்கட்டும், அதெல்லாமே அவங்களுக்கு தேவையில்லை பிகாஸ் ஆல்ரெடி ரிப்பல்ஷன் வந்துட்டே இருக்கு. ஸோ அதனால ஐ டோன்ட் வாண்ட் டு ஹேப்பன் தட். Now electronegativity. For நம்ம atomic radius பத்தி படிச்சிட்டோம். We discussed about all the things and all. Then we discussed about the ionization enthalpy. Then we discussed about the electron gain enthalpy. Now the last topic, which is the electronegativity. Electronegativity is the measurement. It's actually ஒரு என்ன சொல்றது, இன்னொரு எலிமெண்ட்டை வச்சு நம்ம கம்பேர் பண்ணுறது எலக்ட்ரோநெகட்டிவிட்டி சொல்கிறது யூஸ்வலி. ஸோ the measure of the tendency of an atom to attract the shared electrons towards itself in the covalent bonded molecule. ஒரு covalent bonded molecules இருக்கிறேன். ஃபார் எக்ஸாம்பிள், if you have this hydrogen CHCl, இதில் வந்து அவங்களோட அந்த பாண்டை வந்து நமக்கு அவங்க கிட்ட வைக்கிறதுக்கு எவ்வளோ அவங்களோட எபிலிட்டி எவ்வளோ இருக்கோ அதை எலக்ட்ரோநெகட்டிவிட்டி சொல்கிறது. Electronegativity is the ability of an atom to attract this particular bonded electron towards themselves. For example, hydrogen chlorine இருக்கும்போது ஹைட்ரஜனோட எலக்ட்ரோநெகட்டிவிட்டின்னு சொல்கிறது ஹைட்ரஜனுக்கு வந்து அந்த பர்டிகுலர் பாண்டை வந்து எவ்வளோ வந்து அதுக்கு பக்கத்தில் கொண்டு வர முடியுமோ அதான் ஹைட்ரஜனோட எலக்ட்ரோநெகட்டிவிட்டி வேல்யூ சொல்கிறது. தட் இஸ் த எலக்ட்ரோநெகட்டிவிட்டி வேல்யூ. நெக்ஸ்ட் ஒன் இஸ் electronegativity is not a property of an isolated atom. As I told you, it comes into the category of covalent compounds. It's not a property of an isolated atom. ஒரு isolated atomோட ப்ராப்பர்ட்டி இல்லை electronegativity சொல்கிறது. Electronegativity of an atom may be different in different molecules. It can be different. ஒவ்வொரு molecules பொறுத்த வரைக்கும் it can be different. ஒவ்வொரு ஆட்டத்தில் இருக்கிற molecules change ஆகும்போது electronegativity value can be different. Electronegativity is not a measurable quantity. It's not completely a measurable quantity. So அது எப்படி ஸ்கேல் பண்ணுறது, அது three methods like Pauling scale, Mulliken-Jeffrey scale, Aldrich-Rochet scale. This particular one is using widely. This also, but not that. Okay. Now Pauling scale is actually like it's commonly used scale for the electronegativity because it is used actually. Pauling scale is actually used for the electronegativity which we are going to study in the chemical bond. And the time electronegativity apply Pauling scale which நம்ம கண்டுபிடிக்கிறதுன்னு படிக்கலாம். Now highest electronegativity சொல்றது it will be going for the fluorine. They almost have the 4 will be the value and this is the chart for the electronegativity. Now here I have to tell you one more thing children. Fluorine க்கு தான் highest, அதுக்கப்புறம் oxygen வருது. எப்போவுமே நான் நிறைய இடத்துல ஸ்டூடெண்ட்ஸுக்கு வந்து ஒரு கன்ஃபியூஷன் இருக்கிறது என்னன்னா, chlorine oxygen வரும்போது மேம் chlorineக்கு தானே ஹையர் electronegativity value. No, chlorine is almost 3 and the oxygen is almost 3.5. Just have a look on this. Okay, in the 3.5 see 4 வந்ததுக்கு அப்புறம் fluorineக்கு அப்புறம் ஹை electronegativity இருக்கிறது அப்புறம் oxygenக்கு தான், அதுக்கப்புறம் தான் நம்ம chlorine வருது. Okay, that you have to make a note of it because when you find the hybridization of this odd electron species and all is there, in that time we are discussing about the electronegativity actually. So that time the ClO3 ClO2 எல்லாம் வரும்போது confusion ஆயிடும். So keep that in mind. Oxygen is having more electronegativity when compared to the chlorine. So factors affecting the electronegativity: distance between the nucleus of the valence shell increases electronegativity value. See, when the distance between the valence shell increases, when there is more size, okay, so what happens? Force of attraction of that particular nucleus to the valence shell electrons decreases. So electronegativity சொல்றது என்ன இருக்கும்? Decreases. They will be having less value, thus electronegativity value. Because when the size increases, what happens? Electronegativity is decreasing. பிகாஸ் சைஸ் இன்க்ரீஸ் ஆகும்போது இப்போ எனக்கு ஒரு சைஸ் என்னோட சைஸ் இன்க்ரீஸ் ஆகுறேன்னா அந்த எலக்ட்ரான் அங்கே இருக்கிற ஒரு ஆட்டம் இருக்கும், அதோட அந்த பாண்ட் எனக்கு அட்ராக்ட் பண்ணுறதுக்கு டிஃபிகல்ட்டாக இருக்கும். ஆல்ரெடி என்னோட சைஸ் ரொம்ப பெருசாக இருக்குது, ஆல்ரெடி என்னோட நியூட்ரான் வந்து நியூக்ளியஸ் வந்து கொஞ்சம் உள்ளதாக இருக்குது, நிறைய சைஸ் இருக்கிறதுனால இந்த எல்லா ஷெல்ஸோட அட்ராக்ஷனும் தாண்டி எனக்கு அங்கே போய் பிடிக்கிறது கம்மியாக இருக்கும். ஸோ எலக்ட்ரோநெகட்டிவிட்டி வேல்யூ வில் பி லெஸ். So Z effective increases means force of attraction between increases, size decreases. When the size decreases means electronegative value will be increasing. Magnitude of the positive charge. Positive charge means cations. Cation increases. Cations means size decreases. So electronegativity will be increasing. When the size decreases, cations means it is less size. I mean cations means it will be having less size now. Less size means electronegativity will be increases. So force of attraction between the nucleus and the valence shell will be increases. Electronegativity increases. Next one is the across the period. Across the period you know that the size will be decreases. Size the decreases. Atomic radius decreases means electronegativity value will be increases. Lithium, beryllium, boron, carbon, nitrogen, oxygen across the period the electronegativity increases due to the decrease in the size. 1.0, 1.5, 2.0, 2.5, 3, 3.5, 4.0. So oxygen is having 3.5. இது மட்டும் note பண்ணி வெச்சுக்கோங்க. Next one from top to bottom. What is happening? Size increases. At from top to bottom the size increases due to the increase in the number of shells. So the metallic the electronegativity decreases. See, atomic size increases, electronegativity decreases. So fluorine, chlorine, bromine, iodine. Fluorine is having 4, chlorine is 3, bromine is 2.8 and iodine is 2.5 from top to bottom. Now some important points. This you have to keep a note of it. This is very important. This first one is fluorine have the highest electronegativity in the periodic table. Fluorine is having the highest electronegativity and cesium is having the lowest electronegativity. Cesium they have highest size, so they have the lowest electronegativity. Alkali metals will have the lowest electronegativity in their respective period. In their respective period, this alkali metals will be having the lowest electronegativity value, and the halogen will be having highest electronegativity in their respective period. Period like compare பண்ணும்போது in their respective period they will be having more electronegativity value for the halogen and less will be for the alkali metals. The test block elements, na? Lithium, sodium, potassium and all. Okay. Now the difference between the electron gain enthalpy and this particular electronegativity. So electron gain enthalpy means ஒரு isolated atomத்திலேக்கு ஒரு electron add பண்றது, right? It is a tendency of an isolated gaseous atom to attract an electron ஒரு எலக்ட்ரானை வந்து இன்னொரு ஆட்டத்தை வந்து இன்னொரு எலக்ட்ரானை வந்து ஆட் பண்ணுறது தான் எலக்ட்ரான் கெயின் என்தால்பி சொல்கிறது. ஆனால் எலக்ட்ரான் நெகட்டிவிட்டி சொல்கிறது இட் இஸ் எ டெண்டன்சி ஆஃப் அன் ஆட்டம் ஒரு மோலிக்யூலில் இருக்கிறது இல்லை ஒரு காம்பவுண்டில் இருக்கிற ஆட்டத்தோட டெண்டன்சி அந்த பேர் இருக்கும், அந்த எலக்ட்ரான் பேரை எனக்கு வேணும் சொல்லிட்டு அட்ராக்ட் பண்ணுற டெண்டன்சி தான். ஸோ தே ஆர் அட்ராக்டிங் தட் பர்டிகுலர் பாண்டட் பெயர், தட் இஸ் ஆக்சுவலி எலக்ட்ரோநெகட்டிவிட்டி. Electron gain enthalpy சொல்றது ஒரு it's a tendency of an atom to get an electron. அது கம்ப்ளீட்டா கிடைக்கணும், நெகட்டிவ் சார்ஜ் ஆகணும். இங்க அப்படி இல்லை. ஸோ தேர் ஜஸ்ட் ஷேரிங் த எலக்ட்ரான்ஸ். இன்னும் கொஞ்சம் எனக்கு பக்கத்தில் வாங்கல, பக்கத்தில் வைங்க. அதுதான் என்னது எலக்ட்ரான் நெகட்டிவிட்டி சொல்றது. It can be measured experimentally, but it cannot be completely measured experimentally. So this is the difference between the electron gain enthalpy and electron negativity. Electron gain enthalpy சொல்றது கம்ப்ளீட்டா வாங்குவாங்க, கம்ப்ளீட்டாக வாங்கி ஆனியோனாக சேர்த்துவாங்க. எலக்ட்ரோநெகட்டிவிட்டி சொல்கிறது நான் வந்து அந்த அட்ராக்ட் பண்ணுவாங்க, அந்த ஷேட் பீரியட் ஆஃப் எலக்ட்ரான்ஸை நான் அட்ராக்ட் பண்ணி வச்சுக்கிறேன். ஓகே, திஸ் இஸ் யோர் ஃப்ளோ சார்ட். திஸ் இஸ் வெரி இம்பார்ட்டண்ட். ஸோ there are exceptions, children. I have told you all the exceptions, which is very important for the periodic classification. There are a lot of exceptions you are going to study on the p blocks elements and d and f also. அது அந்த டைமில் சொல்லி கொடுக்குறேன். இப்போ இந்த இதில் இருந்து கேட்குற எல்லா எக்ஸப்ஷன்ஸும் நான் இங்கே சொல்லியிருக்கேன். ஸோ எக்ஸப்ஷன்ஸ் இல்லாமல் generally I'm telling you from left to right, you know that across the period atomic size decreases, When the atomic size decreases means electron affinity increases. Electron affinity increases, ionization energy increases, electronegativity increases. எல்லாமே சைஸ் கம்மி ஆயிடுச்சோ எல்லாமே இன்க்ரீஸ் பண்ண வேண்டியதாக இருக்கும். Okay, from top to bottom, atomic size increases due to the addition of this particular number of shells. Number of shells increase அதனால atomic size increases. What happened to the electronegativity? அது இன்க்ரீஸ் ஆகிடும். சைஸ் இன்க்ரீஸ் ஆகும்போது கொஞ்சம் electronegativity கொடுத்தா போதும். Atomic size increases, ionization energy கம்மியாக கொடுத்தா போதும், electronegativity கம்மியாக தான் இருக்கும். We cannot attract that much. So this is your flow chart and this is easy from top to bottom and left to right. Top to bottom in the group, left to right across the period. Left to right, what happens across the period? The atomic size is decreasing and all other factors are increasing. Ionization energy கண்டிப்பா கொடுக்கணும், electron gain enthalpy கொடுக்கணும், electronegativity also increases. From right to left, top to bottom, across, in the group, what happened? Atomic size increases due to the increase in the number of shells. When atomic size increases means we have to give less ionization energy, less electron gain enthalpy, and the electronegativity value also is less. So this is actually the how they are working, all the four things, four peculiarities, four properties of the properties. So like there are some exceptions, there is a lot of exception which is especially in the cases of atomic radius and atomic radius also, and in the electronegativity, electron gain enthalpy and the ionization enthalpy. So there are a lot of exceptions. So make a note of the exceptions very clearly, because they will ask you a lot of questions from the exception cases. So make a note of it very clearly, and rest of all the exceptions, there is a lot of other exceptions also. இன்னும் கொஞ்சம் exceptions things இருக்கு. அது P blockலையும் D blockலையும் we can P block elements and D and F blocks now we can sort it out. So I hope this session, this is all, like we have done with the periodicity in properties and the classification of elements and periodicity in their properties. We have done with the chapter. I hope in the chapter clear இருக்குன்னு நினைக்கிறேன். So இனி next எந்த chapter வேணும்னு comment section la podunga. So I will be taking that chapter in the priority base. So we didn't do any questions here. We will be doing all the questions in the live session, as I told you in the previous lectures also. So we will be doing all the questions in the live sessions there. I hope this session is clear, and if you like this particular section, if you understand the session, please do like the video. And also இந்த மாதிரி இருக்கிற நிறைய content related நிறைய chapters lessons எல்லாம் கிடைக்கணும்னா please do subscribe the channel also, and comment down which is the next topic you need it. Okay, so see you next in another chapter, another chapter, and we can just decode all those things. Okay, thank you, bye bye.